Yo. Okay, I'm going to continue the thing I was doing yesterday, making the LSP useful. Um, so yeah, we're going to make the compiler error resilient so that the LSP can still report stuff in the editor. If we look right now at a file like this, so here's we can see the language server working, right? But as soon as I do something stupid, like a semicolon, this is going to say that we expected the end of file but got a semicolon. Okay, in this case, actually, this works. Oh shit, this actually works. Wait, what? This should be different, by the way. But yeah, I was making the parser error resilient, which it is, but this is being parsed by just ignoring the rest of the file right now. Wait, is double semicolon like a ligature? I guess it is. Yeah. So like, and if I save, it's going to be formatted, removing the thing. Yeah, which is also a bug. But yeah, if I do something stupid, like if I do a semicolon over here, then it's going to say that I was trying to compile the error node, right? And then we lose all this stuff in the future. All right. So if I try to parse example here, if I make a semicolon here, oh wait, I know, it's because double semicolons is like, wait, is it treated as two separate things? I don't know. Let's see what it's being parsed as. So yeah, we have unexpected semicolon, and then it has been skipping the unexpected closing bracket. And then we expanded the end of file, but we got a semicolon over here too. So it was compiled as a statement, which is a constant, where f, we're trying to assign to f the function with unit argument, and body being comp time error node. Because over here we have error node. So like opening bracket, module, statement, assign, that has been parsed. including this closing semicolon. One of them, but then the second one was unexpected. All right. Yeah, that. Yeah, the second semicolon was definitely not expected. So what happened is that it said that it was unexpected, but then I skipped this thing. Wait, but this one is unexpected, huh? Hold on. All right, I'll look a little bit into this thing. I was working on the parser a little bit stream, just refactoring it, but yeah, I think the parser is the most difficult thing in being error resilient. Compiler should be easy, I think, but we'll see. Let me just enable the logs here, and we'll see what is being parsed. Okay. Over here we say unexpected semicolon. Yeah, so we have unexpected semicolon, and I have parsed so far module statement this, and we had an opening bracket. Right. Oh, I see. It was actually not. Yeah, it should have been skipped, but it was not skipped. Yo, Athano. Hello there. Hello from Evan MMO. Wait, what? I was rated by Athano. Evan rated my offline channel. Alright. Shout out. So who should I shout out then? Athano or Evan? I'm gonna do both, right? How are you guys doing? Shout out Bluepin Studio. Is Bluepin Studio streaming? I don't think I saw guys stream. Five years ago. God playing Google Chrome. Nice. Seems like these streams were really entertaining. Why did these stop streaming? Linux, Rust, shit, this guy's a real dev. I'm not doing Rust though. I'm doing OCaml now. I've switched. I'm making my own language. Yes, it was being written in Rust. Now I'm rewriting it into OCaml because Rust is compiling too slowly. That is a dev. Hello, hello. Nice. There are more videos. Clips. Wait, what? Oh, no. No, all clips. Oh, there's a lot. All right. Wait, I think, oh, no, I already followed. Wait, what? I was following the Blueprint Studio even before it, I guess. All right. All right, thank you guys for the raid. Oh, how's your game? How's your game, Evan? Are you working on your game a lot? Let's see what Evan was doing. Wait, they were talking about Kuviman? I think Kuviman is bad? What? Says Athano? Unfortunately, I never heard a drama involving Kuviman. What do you mean, unfortunately? Isn't that a good thing? If you're not involved in a drama? I like your offline background on the stream. You should add the trees on the outsides though. Feels like a little plain here, you know? Like this repeated texture of the grass on the outsides. All right. So I'm working on a programming language here, right? I'm making my own programming language, and the idea is that I wanted to work with like VS Code and editors and stuff. So we want the language server, which is the thing that is allowing me to like have these like squiggly lines showing me the errors, so that I have the syntax highlighting and like auto completion and like other things. So like over here we have stuff like the inlay hints that shows me the inferred types of things, right? So, for this to work better, I need the compiler to be error resilient. So if we see an error, we should not stop. We should continue compiling, ignoring the errors, just like if it was a JavaScript or something. So that's what I'm going to work on. So like, for example, I'm writing code like over here, hello world, and I press another semicolon. You see how everything disappears? Because now the code doesn't compile anymore. We need to stop that. We need to actually continue compiling. So there is a bunch of things that needs to be error resilient, which includes parser. Parser is technically error resilient already. Like I can parse the code with errors, and then it will just give me some error nodes in the syntax tree. But like it would be better if it gave me something that is looking more like it should like guess better at what I actually meant, even if we have the errors. Devs dev, hi. Yesterday I somehow managed to mess up the path and couldn't use sudo. Nix package installation was interrupted and messed up my PC. Today I'm back on Arch. Wait, what? How do you even do that? What do you mean you messed up your path and couldn't use sudo? Nix package installation was interrupted and messed up my PC. Like, how does it even mess Nix package? What's the Nix package? Well, if you're back on Arch, what were you trying to do? Were you trying to install Nix OS? Or what? You can install Nix on Arch, right? It's in the official packages even. You don't, yeah. I don't know what you were trying to do. It's weird. If you're using Arch, it seems like you should be able to follow documentation, right? That's what Arch is about reading the fucking manual, right? So I don't know. I don't know how that could happen to an Arch user. All right. I need to debug this thing. Yeah, so the problem is that this semicolon over here, the second semicolon, it was not skipped, so that while I was parsing this, it was not skipped, and so the closing bracket was not matched with the opening bracket. And why was it not skipped? It's because we have in the parser over here, try skipping token because it's going to be an error, right? So this is a punctuation, and is it in the continuation keywords? Not. Is it in the next keywords of the root? Not. But it is over here, right? So here's the thing. I'm not trying to skip the token if I can start a new thing. Okay, if I can start parsing a new expression with the semicolon. But in this case, it makes no sense. In this specific case, it makes no sense. So this logic should be improved. When should I skip a token which I don't know what to do with? Only if I don't know what to do with it, right? I think. I was trying OmniSharp with Nix shell and interrupted it. Next thing you know, NixOS no longer finds Nix sudo and NixOS rebuild. I tried to install sudo by Nix shell while I had time, and I got permission error. You need sudo to do that, lol. It was on NixOS. Weird. All right. Okay, so I think so, like literally the idea is that I should only skip the tokens if no one knows what to do with them. So who can know what to do with them? We can know what to do with them because I can continue something that was like parsed up the stack, that is still parsing up the stack, so that's why we can check the continuation keywords. But maybe this check is not necessary. I don't know. I feel like if I remove this check, it's going to... I'll do it correctly. I didn't want to work on parser today, though. Do, 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 do. So the problem is, once again, is because I can start the new value with this keyword. But a new value, right? A new value means that I can basically say something like ABC here, right? This technically is correct, right? Syntax. So like this could be just ABC semicolon, basically, is what we're saying. So because of that, we are not trying to skip the semicolon because it can be part of the expression later. But semicolon always needs to be following another thing, another expression, and then semicolon, right? In this case, it's not really going to be following anything, right? So maybe I should check this thing. So this thing over here, this if, says that I can start a new expression which starts with this as a keyword, right? But that's not the case about the semicolon. The semicolon starts with a value followed by the keyword. So it's this if that I'm checking. So if I don't check it though, if I just comment this out, what's going to happen? Then as you can see, wait, nothing works then? It says skipping unexpected, this one. Wait, what? Now it is skipping this thing for no reason. Wait, what's the reason? Yeah, because like this is a value followed by the keyword, which is the thing. But I should not skip it like that, because I'm parsing This is a keyword? Yeah. I mean, there is no difference between keywords and like symbols, which are like keywords, right? What's the actual difference? The fact that one is letters and one is punctuation. It's the same thing, technically. Technically, it's the same thing. It could be like, I don't know, I could replace this with a fan, right? I could replace the const with like some symbols. Opening bracket is also a keyword for me. I don't treat it anything special. I could replace the opening brackets with like begin and end instead. There is a slight difference where like the lexer actually like checks that it's a punctuation or an identifier, but an identifier can be a keyword and a punctuation can be a keyword. Both of them. Hello, Remarch. Remarch, you didn't have to write the error resilient parser for your shame, right? You chose the easy route, where you just use the existing Rust parser to parse the code. Yeah. I'm just trying to think what should like be the so like basically the idea is that I should sometimes skip the tokens and sometimes I should not skip the tokens, right? Why? So like this one, for example, should not be skipped, obviously, because I can continue this. I have parsed this, right? Let me actually see what do we have in the logs here. What's happening? What's happening here? X1, 2, 3. Oh wait, I wanted to comment this thing and see what's going to happen then. There we go. So yeah, I was following with the keyword closing bracket, and then I'm trying to follow with a keyword, trying to follow with a value, That all failed. And so I was skipping. Yeah, so like basically what happens is something like this. I have successfully parsed the opening bracket and the closing bracket. And then after both of those, maybe there is like some syntax rule that can like be followed. Right now we don't have it, but like in theory we could have like syntax that involves opening closing bracket and then some other stuff. So then I see this thing, and then I see this thing. I cannot follow this because there is no rule saying opening bracket, closing bracket, and then this thing, right? So I cannot continue with a keyword or with a value, so I'm skipping this, right? But I should not skip it. I should not skip it because I can continue. It should be in the continuation keywords, actually. Hold on. So, like, it should be over here. Why is it not there? Why is it not there? Oh, I see. Yeah. No, that actually makes sense. So, like, I have not finished parsing a value, right? I need to first finish parsing a value, and then I expand this value, specifically the opening and closing bracket. We, like, need to make sure that this is just, like, some value, which is the argument of the function, right? And then, after we have finished that, then we, like, expand it to this. You started writing you started trying to write a full language, and then you was like, nah, you will never match the dev ergonomics of Rust. Just piggyback. Yeah, I think that makes sense. Okay. Yeah, that's literally why we are checking this. That's literally why this if is here, right? Because I'm going to finish parsing the current thing. I'm going to make this a value, and then the value is going to be followed by this keyword, right? The only difference maybe that I'm not checking here for is the priorities. So like sometimes this doesn't make sense, right? Sometimes this doesn't make sense. Why would this not make sense to check this? Because why? Because the value that I'm going to parse, the value that I'm going to parse is going to have some specific priority, then I'm going to follow it with a keyword. But that rule doesn't it doesn't accept the value of the priority that I'm going to parse. All right. Not smart enough to write a trait system. You just didn't think about it. I think trait system, I don't know. Technically I didn't implement it yet either, right? But I think it's not that difficult. We'll see. There are always details, right? Like, I mean, parser is not that difficult, but then like when you need it to be error resilient, for example, or if you want it to be having, if you want to have an extensible syntax, then it becomes more difficult, obviously. Yeah, so I think over here I just need to check for the priorities. So like if I follow the value with the next keyword, then I can know what are the priorities of the values. Can like I have a filter there. What real world compiler only has the requirement to be a text in program out thingy? No. Oh, Good morning, two-step. How is the resilient parser going today? I'm going to improve it. I just started. I'm going to improve the parser a little bit maybe, and then I will work on the compiler being resilient. The compiler should be simpler, a lot simpler. I feel like parser is something that is literally the hardest part of the project so far. And I'm going to think about it more. Yeah, so basically over here, I'm trying to find the rule that starts with a value and is then continued with a keyword, like that. Right? So if there is no such rule, then I'm not going to do anything. But if there is a rule like that... Wait, if there is... Wait. Yes, if there is no such rule... then I'm going to skip it, yes. That's right. But if there is a rule like that... What kind of strategy are you using to make parsing resilient? I'm skipping the tokens and generating the AST with error nodes. Basically the most difficult thing here is trying to figure out when should the token be skipped or not. And that logic is something that I don't understand fully yet, like how it's supposed to be, right? Because there's options. When I see code, when I see code like this, right, where we have a semicolon, right? Because right now my syntax doesn't allow for just a standalone semicolon, right? So should this semicolon be skipped, or should I just try to, or should it, or is it like, or is it this semicolon actually is valid, but I should treat the thing that is before that until like some beginning to be like a finished thing, which is followed by a semicolon. You know what I mean? There is two options here. Either this semicolon is actually the one that is there on accident and we should skip it, or the semicolon actually has a meaning and it's following some expression that I have not closed yet. You know? You found this blog helping. Yes, I was reading that yesterday. I mean, not reading, I was skimming through this. I'm doing the same thing, as far as I understand. It's just their parser is not extensible, so the rules that they have when you should be skipping a token, right? When you should be skipping a token. So like we have the duplicated comma, right? Like in this example, we have a duplicated comma. It's like the same as my current example with a duplicated semicolon, right? So we want to skip here, right? And if we don't, then the syntax tree is going to be a train wreck. This is literally what I'm having right now. So so in this case of this article, the rules, because the syntax of the language is fixed, right? You can, for like when you're parsing specifically the arguments of a function, and then you see like something, right? Then you skip it, right? Like the rules are very very hard coded in this article, is what I would like to say, right? I want to write a generic parser which is extensible, so that I should not like I'm not writing a function to parse every single expression, right? We just it's more like a parser generator what I'm doing here. So I should generate these ifs somehow, given the rules of what is the parameter list, right? So my rules, once again, they look like this, right? For example, yeah, this over here, this is the then, which is the semicolon. So it's a value followed by a semicolon followed by another value. And then there's a slash n for formatting reasons. Yeah, and then this is like right associative thing. So like I just define rules like that, and then this set of rules is just generating me the parser automatically, and then I can also inject into the parser the rules dynamically, which makes like the parser actually extensible. And so I should not only generate the way to parse this thing, but also I should generate the rules of when the token should be skipped or not, right? So what do they actually say here in this, right? Why do we skip, right? They say over here advanced with error expected parameter. So they have actually skipped the thing. They skip all the tokens that are not param list recovery, right? And this is a hard-coded thing, which means that they only break out of the loop if they see an arrow, a curly bracket, and a function keyword, right? But why is this choice? Why is this choice of things to break out and all of the other tokens should be ignored? Why? So the reason is like they call it first and follow, right? What is first and follow? So there's a first set from the formal grammars, right? That's like from the theory, I guess. That's what they call it. So first, as far as I understand, is basically like a keyword that a token, right? That can be used as a first token in the parsed syntax node. Follow sets are ideas from LL parsing. Yeah, I don't know what is LL parsing. Maybe like but I'm pretty sure that's what I'm doing. And then the follow ones are the ones that you can use to continue parsing something that you have already started parsing. So if your node is an inner node of another node, so that you can follow the parent node with a token, then it's in the follow set. Right? There are tokens which can occur first in a state and those which can follow a state. Yes, literally, right? So like I have the same thing. I think I'm doing literally the same thing. I did not once again read the theory fully to be like 100% sure, but I'm pretty sure that I'm doing the same thing. I'm calling the things a little bit different though. I'm calling the things the continuation keywords instead of the follow sets. So continuation keyword is is basically the tokens that can be used to follow the state as a keyword, literally. Although, okay, you know what? Actually, maybe that gives me an idea, right? Because yeah, so like when I see this set of rules, I'm constructing the tree, which is like the state machine of parsing the syntax. So I'm constructing a state machine, which is I need a break for like a minute. Hold on. Good morning, Barry Michael Doyle. All right, so just like I was saying, what was I saying? Yeah, so like I'm like what's happening in with this like syntax rules is I'm making a state machine for parsing a single rule, which is like a tree data structure, which like if multiple rules have the same prefix, then they will be having the same the same prefixes are merged into the same path in the tree, basically, right? Yeah, so we only have the branches when the rules diverge, right? Yeah, there you go. So we have in this tree, every node represents the parsing state, right? And the path from the root to the current node is what I have parsed so far, right? So if I have parsed if condition and then I can follow with the then case, which is a value, right? So in this tree we have the edges, which can be either a keyword. So I either follow with a known token, which is a keyword, what we call a keyword, right? Or we follow with a value, which is which needs to parse thing recursively. So we start again at the root of the tree and like let's try to parse something else, right? Recursively. That's what I'm doing. Let's see. Is that actually what an LL parser is? LL parser. Is there a brief thing? It's called left to right, leftmost derivation. Like maybe that's literally what I'm doing here. Is a top-down parser for a restricted context-free language. It parses the input from left to right, performing leftmost derivation of the sentence. An LL parser is called an LLK parser if it uses K tokens of look ahead when parsing a sentence. A grammar is called an LLK grammar if an LLK parser can be constructed from it. A formal language is called an LLK language if it has an LLK grammar. Okay, is there like something that's like not like brief? Overview. For given context grammar, the parser attempts to find the leftmost derivation. Given an example grammar G, S into E, E into E plus E, E into I. The leftmost derivation for W, which is I plus I is... I don't understand what this means. It's probably easy, but they don't explain what the semantics of this. I need to like see what is that or something. But generally, there are multiple possibilities when letting a rule to expand the leftmost non-terminal. The parser must choose whether to apply rule 2 or the rule 3. To be efficient, the parser must be able to make this choice deterministically when possible without backtracking. Yeah, that's like that's okay. For some grammars, it can do this by picking the unread on the unread input without reading. In our example, the parser knows that the next token, next unread symbol is opening bracket. The only correct rule has to be rule 2. Right. Yes. Yeah. I guess I have the LL parser. LL seems to mean that you expand the leftmost symbols first. You expand the leftmost symbol first. What do you mean? What does expanding mean though? But yeah, like in general, my parser looks like this. Here's the top level, like, semantics. When I'm parsing, right? So we start with having parsed nothing, right? And then we do a loop. So I'm trying to extend what I have parsed so far to the next minimal thing, right? So if I have parsed nothing, then I'm just trying to parse the first, like, the first simplest thing, which is going to be either expand means like choose it or try to parse it. Yeah, I mean, I guess the leftmost symbol first. I don't know. I guess that I don't know. Yeah, probably. I still don't understand what do you mean. Expand the leftmost symbol first. What does this even mean exactly? But like, I'm always doing it like left to right, and I'm choosing which rule to apply based on the first symbol, basically, right? So when there is multiple rules to expand to, we narrow down the list of rules that can be applied at this position by looking at the first symbol, basically, right? So in this case, we know like that the first symbol is the opening bracket. So the only rule that starts with an opening bracket is the rule number 2, right? So we start parsing this immediately, right? That's what they say here. And then in the step 2, the parser might choose whether to apply rule 2 or rule 3. I don't know what this like S into E means though. Like that's weird. What's S? All right. Anyway, the prefix of the string U of length k equals the prefix of the string V. What? The LLK parser is deterministic push-down automaton with the ability to pick on the next k symbols without reading. I only picked the next one. I think, although in the previous version I was picking two tokens. Expands means to substitute the first non-terminal with the right side. What does this mean? I don't understand what it means still. What's the non-terminal? There's a lot of things to read to understand this. I guess it's all simple. It's all simple, but I'm too lazy to read it. You know, I'm already doing the same thing. I'm pretty sure. Okay. Maybe I will read it one day. Just to, like, be 100% sure that my parser is LL parser. Maybe there is, like, a better... like, Wikipedia is bad. Like, if you look at the Wikipedia on, like, algebraic effects, for example... Right? And you look at this on the Wikipedia effect system. Formal system that describes computational effects or computer programs such as side effects. Like, I feel like when I was reading this on the Wikipedia, it's also not really understandable. Like, the Wikipedia page is bad. Maybe like LL parser, briefly or something. The parser builds a derivation tree starting from the root, the start symbol, and then expanding non-terminals in the leftmost manner. Yeah, I mean, I guess that's what I'm doing. So you always start with the start symbol of the grammar, and then okay. So like you always start with a start. Okay. Yeah, I guess that makes sense. So you always start with an empty one, and then you try to expand to something. So you must have an expression, basically, an E, right? And an expression can be either this expression or that expression. Yeah, I guess. If you can get through it, you can. It can help to understand how to computer the recovery states for a given production, which might be what you're trying to do. Yeah, I think though that I can figure it out without learning the theory. The theory is not that hard. The hard part about the theory is reading the theory. Yeah. Like really. It's like trying to understand what a monad is. For example, I feel like the monad is not really like explained in an easy way anywhere still. I think, but there might be an easy explanation. But I don't know. You just understand it by doing it more like, you know. I mean, parser is probably like easier. It just requires reading, and I'm lazy, you know. Okay, so what am I trying to do here? I'm trying to see the recovery states for a given production. Is there like what's production even? Production rule? Terminology. First B, where B is any non-terminal that immediately follows A in the right-hand side of a production rule. Follow B, where B is any head of a rule of the form B into WA. First conflict. The first sets of two different grammar rules for the same non-terminal intersects. An example is an LL first conflict. First E is B in that, and first EA is BA. When the table is drawn, there is conflict after the terminal B of production rule S. First follow conflict. Yeah, let's ignore this. Close. Right. So I need to basically, it all boils down. Should I skip the token or should I not skip the token? Right? And I should skip it if I cannot do anything useful with it. Is the thing. So like, how do we determine if I can do something useful with it? If I can continue parsing something that I have already been parsing, then yeah. Otherwise, if there is, so this rule over here, I'm saying that if I'm going to finish parsing a value and then follow it with a keyword, which I am seeing right now in front of me, then I should not skip it. So return none, right? But it's not always the case. It's only should be the case if the priorities match. Wait, LL parsers don't have the priorities in them, right? So I'm not exactly having an LL parser, I think. LL parser, rule priorities. Is there such a thing even in an LL parser? Rule priorities to resolve ambiguities and determine the correct parsing path with multiple grammar rules could apply to the same input sequence. Now, that's not exactly like the priorities that I am talking about. I'm talking about like operator precedences. They can be adapted to handle operator precedence. Is that their primary strength? Yeah. Yeah, I call it priority. Maybe it should be called precedence instead. But yeah. So for every syntax rule, we have the associated number, which is its precedence, right? And then when I see the inner value, this must be, if I don't specify anything, it must be strictly greater precedence, right? So this over here can only be any rule that has a higher precedence, right? So for example, when you have a plus for addition, right? When we have a plus, we should have like the first value and the second value. They should be higher precedence. But the first value in the plus specifically can be the same precedence, which makes it to be left associative. Yeah, and that's like the only thing. So for every value, it's either like we either say that it should be the greater precedence than the current rule precedence, or greater or equal. Or it can also be any precedence. In case we are inside parentheses, we like reset the precedences over here. Yeah. Okay, so over here, this means that I need to check the precedences, basically, because I might not be able to do anything useful because of precedences. So I can finish the current value. I can finish the current value. I can get, as a result, a value. Okay. So here's my current parsing state. Current parsing state has the node in my like automaton, right? Whatever. So, and for every node, I have the priority range, so precedence range of all of the rules that can be parsed. So, like, I'm currently in the, I have parsed some prefix of some syntax, right? I have parsed some prefix. For example, I parsed if without the rest of the if, right? Just the first keyword. So we can know what are the precedences of the rules. I know the range. I know the minimal precedence and the maximum precedence of all the rules that are starting from this state, right? And so and when I'm going to start a new thing over here, I'm going to like, this can only be applied if the rule that I'm going to finish is going to satisfy the filter of the precedences of this value over here as like the first step. So this filter is stored in this node in the previous value filter. So basically, this over here, right? I have basically in my data structure, we have the path which starts with a value and followed by this keyword, right? So what is the value filter for this value, which was before the keyword, right? So we have this over here. It's a filter. And what should we check with this filter? Everything that we can start. The filters, there are only 3 kinds of filters. Either greater than the specified priority, greater or equal than the specified priority, or any, right? So the only one that we should actually check is the highest priority of a thing that I can finish. I think is the highest priority of a thing that I can finish. So I think this should be It's not only about like the current one, but also about the things up the stack potentially, I think. I think Sumo Camel has a built-in priority queue and max heap. How about skip until you find something lower than the lower bound of parents' precedence? I don't know about the precedence before I actually finish the syntax, right? Because, well, I mean, technically in the previous implementation, as soon as I start parsing something, I already know the precedences. As soon as I start a keyword, at least. So skip until you find something with lower than the lower bound of parent's precedence. Like we have in the context, like all right, I know that I should parse only the rules that satisfy the filter. Is that the one that I am actually am thinking about here? One thing I don't know, what other languages don't call data structure library same. One thing I don't know, what other language don't call data structure library same. Rust, C++, and Java call collections. Either have discrete library for each. There's just like the ordered sets. There's just a set is basically can be used as the priority queue, I guess. I don't know if there is a dedicated priority queue. I don't need it though. I don't need the queue here. But like I cannot skip until I find something with lower precedence, because in order to know the precedence of the thing that I'm skipping and to finish it parsing, right? But I only see the token. Token doesn't have precedence. Precedences are only about like the full expressions that are parsed. Map plus link list, kind of similar design. I'm not sure what you're talking about. What you're trying to say? Um. All right. I need to start making progress. Somehow. Node. So we have the filter of the value, and now I want to know what is the value that I can finish, right? I can try doing the current state, right? I can say state dot node dot priority range, right? So these are the ranges of the rules that I can of the values that I can get, basically, right? And can I say rule syntax rule priority check filter with range? Is that what I want? So I just check the range with the filter if the range has any overlap, right? Yeah. So if if only if we check, then only we do that. Priority range. This is an optional one. And the filter is also optional one. Okay. Match. State, node, priority range. Node, pref, value filter. Some range and some filter. When check with range filter, then return none. And in other cases, I don't do anything. Like that. Okay, will this work? Let's see. Maybe it will work for this specific example though, and it will not work for other examples. Just skip until semicolon and call it a day. Yeah, I can like hard code it, obviously. Yeah. Okay, let's see. So I'm going to restart language server. This right now parses, and I do a semicolon here. It is going to say that skipping unexpected semicolon, right? So there we go. It has skipped it successfully. In this specific example, it works. But I don't know. Let's say that there's like, I don't know, a plus, right? So the plus is also unexpected, right? If I say 2 plus, what's going to happen then? Then I was trying to compile the error node. But this is actually correct. Okay, like the 2 plus is obviously an unfinished thing, right? I feel like this really needs some tests. How do I test the resilient parser? Like I need to actually like write some incorrect code and then assert that it actually parses to some specific thing. This feels like it's working right now. But maybe it's like a hack that I just did. I don't know. What if I do this 2 plus plus? Check type check failed. Okay. Unit is not in 32. Yeah, this over here actually makes sense. So because module result must be a unit, but the final thing is just 2. Yeah, okay. In this case, we have a type check. I don't know. Maybe this is good enough. Maybe this is good enough. Maybe this is good enough. Improve? Question mark. Skipping token logic. All right. Okay, now we go to the actual compiler, right? So once again, if I try over here to say semicolon, then this works. What if I do a semicolon like over here though? Skip an unexpected semicolon. Okay, nice. What if I do? Yeah, see, I still have like the completion, the LSP working here. Did you stop parsing, or can you hover stuff after this error? I can. No, I don't stop parsing. You see the inlay hints here, so which means that it works. I can hover things, yeah. So the parser errors are actually being ignored. If you see over here when I parse, this one specifically doesn't even give me the error node, because this over here is just being completely skipped and ignored. Sometimes I do generate the error nodes. To generate an error node, I need to say, like, let's say S plus, for example, right? There you go, like this. What does this mean? This over here is an error node. This has been parsed into the thing where I try to assign to the thing, which is S plus, right? So like S plus is a thing that we don't know what it means, right? So this is like the node, which is the error node here. Right? So I'm trying to assign to the error pattern, right? And so I'm trying to basically convert this error syntax node into the pattern, and it doesn't work. So the compiler over here stops, which means that I stop having any hover information and stuff. So that's where when we are actually going to make the compiler error resilient too, the compiler needs to ignore the error nodes and continue working. We need to ignore type checking errors and like not found symbol error, you know, all of those things. So here's the compiler. We're just going to find in folder error, right? We're not actually. I'm just going to go to the error, right? And I'm going to say that the function that reports the errors, it was previously never returning, right? Where, because it was raising an exception, but now we're going to raise a resumable exception, so it's going to actually return nothing like this. And because we return nothing, we're going to see compilation errors here, right? So over here, for example, I stop compiling because I cannot find a symbol in scope, right? But I should still return something from here, right? So this should still return something. And I feel like if I cannot find a symbol in scope, then what I should do is I should just imagine a symbol, right? Imagine like if it actually was existing there. So I'm going to return a new symbol where name is symbol, and there's no auto-completion in OCaml, of course. We are going to hallucinate, right? We are going to make the compiler work like an AI. Right. I wish OCaml gave me auto-completion, but it doesn't. Create. Oh, there we go. I start typing one symbol, then it does it. So I'm going to create this symbol with identifier name, and then the auto-completion doesn't work. So we also need to have span, type, and references. Okay, so span is identifier. No, not identifier. The span is like from, I guess. The type of this is going to be we're going to not know what the type is, so it's new not inferred type, right? And references is empty. This. By the way, are you going to make the program runnable even with the compilation errors like Rock does? Yes, that's like another thing, right? So we are going to be able to evaluate. So like it's just because the compiler, since I need to make the compiler error resilient, compiler includes the interpreter, right? Because we need to run code at compile time, which means that the interpreter needs to be error resilient, right? So we need to ignore the errors in the interpreter too. Yes, that's going to happen. No recursive imports. If I'm trying to import a thing that has a thing, all right? So yeah, and this also means, by the way, that the values can be a recursive. Can have errors, right? So so the types can be errors, the values can be errors, everything can be an error. So we have a value error, the type that is an error. Right? We have an expression which is an error. The pattern that is an error. Everything is an error. So if I print the type error, then error. And if we have the value, which is an error, we print error. If we want to know the type of the value, which is error, then the type is error. The type of the error is error, right? Oh, in the inference. So yeah, in the inference now, what is this fail, right? When I was doing the inference, we are going to say we were saying that type check failed. But this is also going to return unit here instead of raising an exception. Which means that the fail should just return the error type. This returns type shape. Right? Pattern matching is not exhaustive. Yeah. And then if I'm trying to unify the error with anything else, then we are going to have the error. And I guess the other way too at the same time. Anything else with error is going to result in error. So the error like propagates it automatically. It is infecting everything. Everything becomes an error, right? So when I say no recursive imports here, I will just instead return the value, which is error here in the end. Like that. When I initialize the compiler, the field is not there. So what is this? This is when I'm trying to figure out the type of a field of an object. If the field is not actually present in the thing, then I'm going to say that the type of a field is what? Should the type be error, or should the type be like not inferred type? I feel like it should be a not inferred type. So, like I should allow it to be anything, basically. Like this. And if an object that I'm trying to get the fields of doesn't have any fields, because I'm trying to get a field like, I don't know, of a string, then it's like the same thing. Just return the new not inferred type. Apply must be expression. What is this? So yeah, we have like yeah. Yeah. So if I return and basically if I'm trying to call a function in a place of a pattern, for example, then it's not going to compile. Right? So we should instead say, I want to say something like initialize error of this kind and this span or something. Let's do that. I want to have a function which says initialize error, which for a compiled kind and a span gives me a. So it's going to be function span into span kind match kind with. So we can compile expression, which is in this case going to be expression. So it's in the end here. It's going to be expression error into initialize expression span. If I'm trying to have a pattern, it's going to be pattern error. Initialize pattern. If it is assignee, going to be assignee expression. Initialize assignee. If it is the type expression, then we have a type expression error. Initialize type expression. Right? Is that all the things that I should do? The definition is less general. I hate this. Okay, and then there is no yeah, so like in every expression type, right? We need to initialize the expression error. Like that. Okay. Expression error, pattern error, type expression error, and assignee expression error. Like that. And I print pattern. We do that. When I print type expression error, when I print assignee error, expression error, just print the red error. Okay. So now when I evaluate the type expression, if I'm evaluating the type expression, which is the error expression, I feel like I should this just not be type new not inferred, or should it actually be the error node? I don't know. I don't really know. Like both of these options, like how much do I want the errors to infect everything? How much do I want the errors to infect everything? I don't know. I can either say that the type is the error type here, or I can say that it is going to be just inferred based on some other usage what the type is. Maybe in this case, let's say inferred error. Sure. We'll see. I'll start by infecting everything maybe, and then we'll see if I should uninfect somewhere. Expression error. When I evaluate expression error, I should just give, well, I mean, and the expression error obviously can only be evaluated to a value which is error. Okay, that makes sense. When I try to assign to an error assignee, then I just don't do anything. I just don't do anything. I ignore the error in this case. When I try to pattern match, where pattern is an error, I also ignore it. I ignore the fact that I cannot pattern match. Okay. When I want to inject assignee bindings, if we have assignee error, we don't do anything. Inject pattern bindings, if we have pattern error, we don't do anything. If I try to initialize the type expression type expression error, then I don't do anything. I don't do anything. If I have if I try to initialize the pattern error, then the type, like what should be the type of the error pattern? I feel like this actually should allow me to pattern match anything. So it should be a new not inferred type actually. I think maybe. This reminds me of that saying: "Be conservatives, conservative in what you do, be liberal in what you accept from others." For some reason. Should the type of the error pattern be an error or a new not inferred type so that we still have the type information there? I feel like the new not inferred type. If I initialize the assignee, which is an error, then it's the same. It should be should allow me to have the inference of the type. If I have an expression, which is an error, then what should be the type of that expression? Similarly, new not inferred type. Then must be expression. The return initialize error span. Okay, yeah, this over here is just like when I'm trying to compile something that is of wrong kind. Like a statement cannot be a pattern, right? Then we will return the error nodes there. Initialize error span kind. Initialize error span kind. Initialize error and kind. To do expression. This is a to do here. What is this? A placeholder. A placeholder expression. Yeah, a placeholder expression is going to be for the things that are going to be inferable. I don't have that yet. Initialize error. All right. What do I have here? Included file is empty. If the included file is empty, then I should just return the AST, the AST error node. Kind of. AST. This returns AST. AST error takes one argument. Which is what? Why can I not go to the definition? Hate this thing. That's what I want. Or initialize error. Span kind. Field must be identifier. So when I say a dot b, right? This is the dot syntax. The thing after the dot must be identifier. Actually, like in the future, it's not going to be identifier always. I think. But for now, if it this must be the identifier, then I think I will just return the error node here. I feel like I just returned the error node here. Initialize error span kind, and this should be just like, I don't know, returned like that, which means that to be able to return from here with return. Okay. What is this? Unused rec flag? Why is this highlighted as an error? It's a warning. Stupid. Oh, camel. Okay. Over here we have a use dot star. So I figure out what's the type of a thing that I'm trying to use. And for now it must be always a tuple, because I cannot use anything other than the tuple. But we should continue just saying that the list should be empty here, I think, of the things that I import. Yeah, sure. Use a star must be expression, initialize error, span kind. Initialize error. Initialize error, span kind. Initialize error, span. Over here, what is this? This is make binary operator. Make binary operator. This is me evaluating the binary operator. This should return the value error if we pass as an argument, not a tuple. Okay. Okay, so we're almost there. So when I try to compile the error AST node, this should always return the error expression, I guess. So I feel like I should not even report the error, kind of. Right? I mean, sure. Let's keep the error for now, but I feel like this is not even necessary to be reported, because we'll already have reported it when constructing the AST node, which is the error. I'm just going to say error initialize error and okay. When I want to assign to a string, strings cannot be assigned. Initialize error find. Strings numbers cannot be patterns, not yet at least. initialize error find. And then if we so core syntax handle returns a unit. No, it doesn't return a unit. It's because if there is no core syntax for this, we should just return error node. Is error span span is ht span. Yeah, like this. Okay, and then this should, if I need to compile syntax rule that. Yeah, this is just a to do here for me. It's fine. Initialize error end. If I have this syntax node, it's also a to do. Yeah. This is for extending syntax here. Okay, when I'm trying to hover in the LSP, if I want to hover over the type expression error, then this is the inner. Yeah, errors don't have inner expressions, right? Pattern error don't have any inner expressions. A CFINAE error, expression error, and okay, and then the inlay hints for the error nodes. If we have expression error, it's going to be none. That CFINAE pattern expression. Okay, we have successfully compiled everything. Now let's see if it actually works. Restart language server. It doesn't because I am still throwing an error. Technically, I'm still throwing an error. Compiler error over here, right? I have changed the type signature here, but I didn't change the fact that I'm just raising an exception. So instead of raising an exception, the error is not going to be an exception. It's going to be now the effect. It's going to now be the effect. Type underscore effect t plus equal error, which is error into unit effect. That. So instead of raising, we're going to say that we're going to perform this thing, and we don't have to print the thing anymore. This is compiler error, and similarly to that, what plus equal? This is an extensible enum. I don't know what language you are familiar with. An extensible algebraic data type. So like in the end, after everything has been compiled together, it creates a single huge enum basically of everything what an effect can be, or an exception is done the same way basically. As to the union, well, it's not the union. It's a sum. I mean, yeah, you can call it a union, I guess. It just adds another variant to the type. Yes. This and then the inference. Inference is the same. Inference base error is going to be also type underscore t plus equal error into unit effect. Yeah, and it's also using the generalized algebraic data types feature at the same time as the extensible things. So now I cannot just register a printer for this as an exception because I cannot handle, like this is basically saying how do I handle unhandled things, and now we will have to catch these in the main manually. So main, right? Yeah, similar to this. We have so this over here is parser error. Then we will have cast inference base error. This will be inference error. Error print. Cast inference base error print. Right. I also need the print everywhere. Here. Oh wait, this already has it. Yeah. Inference. And this over here. Compiler. Code I can actually understand as a F# programmer. Nice. Hello. Welcome. Can't really say that I am an OCaml programmer. So yeah, inside of the main, I'm not going to say this. I'm just going to say this. So we have inference, and we also have the that's the compiler error. Compiler error, and it needs to be re-exported. From the compiler module itself. Oh, I'm just including the error here. That's wrong. To and say module error. How many lines of OCaml until you are an OCaml programmer? I don't know. How much do I have so far? I have already 7,000. I mean 6,000. Right? Is that a lot? Compiler error. I'm going to remove this here because the compiler is never supposed to have an error, right? Yep. It is never supposed to have an error. Option bind. Yes. Yes. So this is now an effect. Similar to this over here, we have a parser error effect. So when I'm trying to compile the thing, I'm going to handle the effect, compiler error, and I'm going to have the effect inference error 2. Why Camel? You didn't like Rust? No, I like Rust. I like Rust more than OCaml. Except when it compiles for an hour. But yeah, I like abusing the language features. And we are starting to abuse the effect system of the OCaml too a little bit. We're going to abuse it a lot. Technically, as far as I understand, at this point, OCaml actually suggests that you don't use effects for anything other than asynchronous, I think. But I'm going to do it anyway. In this case, this is literally a resumable exception. So we have an exception, and then we continue after the exception has happened. Compiler error. Type error. Diagnostics. Okay, I'm going to copy paste this here. I think. What is none? None. We're just going to continue here, and there. Okay, we're just going to copy paste for now. What cast system are you going to abuse in the next rewrite? No, I mean the cast systems are designed to be abused, so it's not really an abuse if it's designed for abuse, right? Okay. Maybe they should not be separate things, like, because I literally copy paste this here, and it's literally the same thing. So we don't have a compiler error. We don't have parser error either, by the way. Right? Yeah, we don't have parser error. Let's return parsed result. We just return result here. What is this? Any other exception happened? Yeah, sure. So for now, it can still not be parsed, I guess, and which means that it can also not be compiled. Right, we don't have this, we don't have that. So the file state can only just holds the diagnostics like this. Parsed and compiled. Parser error, compiler error, type error. And then I just remove this and I just return the diagnostics because we just have them already, right? Like this, that's the entire diagnostics. Okay, let's see if this is all that I needed to do. Is this all that I need to do? I restart language server. Okay, well, I see the errors. I definitely see the errors here, and I also see the inlay hints, right? What is this? Why is the type of f inferred to be unit into this, which is like an empty tuple, I guess, for some reason? So trying to compile error node string. Unexpected equal sign, because it was like s plus, sure. That makes sense. Oh, because it's a module. Yeah, because okay, that makes sense. Because it's a module without any variables in it. That makes sense actually. Okay, and then S is not in scope because like foo is the thing that doesn't contain it, right, anymore. Because this doesn't. So yeah, because S was supposed to come from me using the foo.star, right? But the S is no longer defined here, so it does not exist anymore. But we know that the type of it is string. So I still know that the type of it is string, even though I don't know what it is. I know its type. It's a string. Okay, let's try something else then. Right, so this Does it successfully? Okay. What about something else? I don't know, guess a number. What if I say over here that guessed, so like generate an int, a random int is like an int 32, right? What if I say that this is a string, right? What's going to happen? It's going to say that over here, type check fails. String is not an int, right? Okay. But then it says that the type of the gen int32 is now an error into error, right? So why does this happen? Because in the inference, so this means that if I say something else, let x be std gen std rng gen int32, right? So yeah, you see this is an error into error, and if I try to generate another thing, then it says that the type of x is error, right? And why is that? Because the type of this function was inferred to be the error. So why did this happen? Because I said that this is a string, right? But this was an int. And because it was trying to unify, so like because of that, we were basically, because saying that this is a string, we're basically asserting that the type of this is an int into string. And because that's not the case, we replace the function type with an error. That sounds bad. Yeah, this is wrong. So I think it's just like the inference is a little bit different. I'm saying that if I see an error and any other type, then I propagate the error, right? It infects. The error is infecting too much. We should instead say that if we see an error and something else, then we just go into ignore the error, right? I think if we have an error and something else, and we have something else, an error, then we're just going to return this something. You know, we're going to ignore the errors instead of infecting everything. That makes more sense, right? Maybe? Let's see. Restart. So now this is saying that this is an int32, even although guessed... Oh wait, guessed it still is an int32. Hold on. Wait, guessed is an int32, even although we're saying that it's a string here. It says type check failed, string is not int32. The type check issue is over here. So I am saying that this entire pattern should be a string. Isn't that what I was saying? I feel like the highlights are a little bit wrong here, right? Like, shouldn't this prefer the string here? Because this is in the type ascription. So it's because when I say type ascribe over here, when I say type ascribe, I do that, and then I say that the thing is inferred as that. Okay, that makes sense. What if I say like, what is it like underscore here? Right? Wait, this still says int32? That makes no sense. That makes no sense now. Why is this an int32? I said string. Hello? Wait, now it's type checking here. String is not int32. Wait, what? This makes no sense. This over here makes no sense. What's happening? It's alive. It wants to be an int32. Hold on. To do underscore expression file. What if I try to evaluate this, by the way? What's going to happen? Let's see. I did not. I think the interpreter is still just failing. Is it? Test eval examples. Guess a number. Well, actually, no. We evaluate successfully. We just ignore the errors. We report them to the terminal, but then we don't do anything. Yeah. So over here we have this error. This is the only error. Wait, did I not restart the language server? Maybe. Oh, I just didn't restart the language server. That's fine. It is a string. Wait. Maybe I forgot to restart it earlier too? If I do this, what's going to happen? Yeah. Type check failed. Int32 is not a string. Yes, is an int32. That's wrong. Okay. But this is not wrong. Wait, what? Wait a second. Wait a second. If I restart the language server, then it's reporting a different error. That makes no sense. How would it report a different error if I restart it? I'm doing things from scratch every time anyway. Am I not? You see, I press space and then I go back. And we have this thing being reported in a different span. String is over here, right? Yeah. Yeah. The actual error that I see in the terminal here is different. That's weird. We have a RNG compiler, it seems. My LSP is now just like Rust. Just like OCamls, I guess. Showing me random errors that don't exist and stuff, right? In all of the wrong places. Alright. Okay, let me just commit this anyway. Basic error resilient compiler. Let me see. Why would that even happen? Why would I need to restart it? Let's see what's happening in the LSP itself. Because LSP, it just processes the entire workspace from scratch every time. Right? So it's trying to process a file, and then while processing the file, if we see this, and it happens, right? The compiler default is creating me the new thing. Maybe it's because some of the things that I make as like I think maybe I know what can happen. Maybe I know what can happen. Because I have the what? Like I have natives in the interpreter. Yeah, that's what we have. I have interpreter natives, right? Yes. So so we have a function which is RNG, right? And RNG is a function that has these types, and then this type can be changed to be an error later. Too much effect abuse. No. It's because so like type. It's too much mutation abuse, I would say. Instead of using like pure functional stuff, right? So I have this thing. I initialize the type of the function RNG to be this type, right? But when I'm doing the type inference, this type might be replaced with the error type, right? So I actually change an inferred type into an error type in the type inference, because that's what I'm doing over here, right? If I fail, then I return the error. But maybe that's not what should happen. Wait, maybe there shouldn't be no type error. Should there be no type error, actually? No, it must. And like later, because it's an error, because that thing becomes an error, it affects the other things, you know? And I am, yeah, because like, and then over here, the errors are not infecting anymore. Like, you know what's happening? Let me show you. We have this thing. We have a function. We have a function, right? We have a function that takes an int32 and returns an int, right? Just an int, right? And then I'm trying to basically assign the result of this function to a string, right? I'm trying to assign the result of this function to a string, right? Because that's when I'm saying let. So we have a string. And what we're trying to do, we're trying to say that these two types are the same. So because these two types are the same, and the string and integer are basically not the same type, what's happening is that I'm saying that both of these result in the in being the error. Right? So I modify my RNG function to be now a function that takes an integer and returns an error. Although later we have an error and an integer, maybe over here. I don't know, it's actually weird here. Restart language server. If I remove this line. String is not int 32, yeah. Still says int into int. I expected to say like int into error. I feel like I should just not unify the variables in this case. If they don't successfully unify, then I should not unify them. Maybe. Right? If the type check fails, then it's just do that. So here's my variables, and I say that I want to unite two variables. Or infer as unite data. Once inferred. Like, should I just keep them separate still? I don't know. I feel, yeah, actually I should. Data once inferred, I just run this thing. Yeah. Okay. I feel like I just do a try catch here. I feel like I just do a try catch here. I feel like I just do a try catch here. But when I unite two variables, I'm supposed to return one of them. And if they cannot unite, then which one do I return? The first one, the random one? I don't know. I guess let's do the first one. Yeah, I feel like I just do a try and catch here. And I'm going to catch effect error. I'm going to yeah, so like I catch this effect. I will perform it immediately again. So like forward it to the caller. But then I should just yeah, so like I don't actually continue the continuation here. I actually break. This is going to be used as exception. And I'm going to just return the A. Technically only this thing can fail. Right. I should have a try catch around that only. I don't know. And then similar to the infer as, by the way. Yeah. Just say try with this. I just perform, but I ignore the continuation. Let's see. So like this still says the same thing, right? If I go here and I restart language server, it's going to say that type check failed. Guest is a string now. Okay. I think I'm just not sure how to like I'm just not sure how to debug this properly. I feel like to debug this, I need to log when the inference happens. I need to then maintain the information where the type variable is even coming from. Anyway, this seems to work, right? To have a string guest, which is actually an integer, right? So what happens if I just try to print guest, right? Because we know that this is a string, so this actually works. Even though I cannot print x, right? Because this over here was supposed to be a string, but I'm trying to print the integer. So what's going to be evaluated here? So now we have an exception, expected print accepted a string, right? So this is where the interpreter natives should also be more error resilient, right? So whenever I do fail, Fail. The CLI is fine, right? So when I try to evaluate a binding which is not found, right, is another thing. I feel like I just return if it is not found. I just yeah, this should just return the error, right? So yeah, I just don't have the errors in the interpreter, but I should. New file error. I'm just going to copy paste it from like the compiler. It's literally the same thing. It's just an interpreter error instead of a compiler error. Past interpreter module error. Right. So over here, I say error that, right? Log error all in scope. Just trace. I don't care. Log error. Yeah, and yeah, log error. Yeah, I need a span here. And the span, which is expression data span. Semicolon this type unit, but expected to have type value, right? So we need to return the value here. So shape is value error, right? This returns value. This okay, yeah, that makes sense. Expected function, right? So I'm trying to call something that's not a function. The result of that is also going to be just an error. So this should be error. Expression data span expected function. Shape is the error. No native like this. Same stuff. Error. Expression data. This is another expression. Expression data span. And then we return like that. Okay. If something doesn't have the fields, say that, and the error. And to use dot star this thing. This just returns an error. If I have an if and the condition is not a boolean. Wait, if we have an if and the condition is not a boolean, which one should we evaluate at the then case or the else case? What should happen? How does rock do it? Is not still here? Rock. Hello, internet. Fast, friendly, functional. Wait, why did I not rewrite it in rock? Why did we go for a camel? Is this a macro? And I have the playground on the like just the front of the thing. Nice. Nice. Should I do the same for cast? So what if I say if 1 then A else B. Okay. It says rock failed with message erroneous. Invalid condition type in if expression type mismatch. But I need every if condition to evaluate to a bool, either bool true or bool false. Right now it's a number of type number star. The error messages are good here, actually. Nice. Maybe rock is a good language. Okay. How do I make it though? Like, can I say 2 plus 1, 2, 3? So it says that we failed. But plus needs a second argument to be num star. Bum, 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 bum. How do I try to run it with error resilience? Anyway, what do I think? What should happen if the condition is not a boolean? What should I do then? Should the entire if result in an error, or should I actually try to guess which one of the branches to evaluate? Probably not. I probably should not, right? Should it be just false? Because it's an error. Error is like false, right? If you're writing JavaScript, right? If you're writing JavaScript, use rand. Like if I say JavaScript and I say like if 1, 2, 3 plus 4, 5, 6, right? I mean, yeah. In this case, it's going to actually evaluate to true in JavaScript, right? Console log true. Right? It's going to be true. But maybe I want it to be the other way around, and it should be false, because like this actually should result in an error, and an error is a false C value. I don't know. It's either that, or I just don't evaluate anything inside of the if. So the opposite of JavaScript in almost all cases. But what is the opposite of JavaScript? Is opposite like not going into the else case? Like there's two choices here. I think this choice that JavaScript is doing is incorrect, but there are still two other choices that I can do. Rush back 99. Hello, hello. Like I can either not evaluate either else or then case, or I can maybe it's like as long as it can be evaluated and has value, not empty, it would be as true. Well, I mean, what does it mean like not empty? Like same as like the in the yeah like I don't think I want to like inspect the actual value. If the condition is turned out to be like a string, should it be like based on whether the string is empty or not? I think that's wrong. I don't want to do that. No. No, that should not happen. The conditions also only should work for booleans, I think. Why is it important to continue and not compile error? Because of the language server needs to continue working. And evaluation is part of compilation. So we need to make the interpreter also be returning something. Okay, let's just return the error here. Fine. I'm not going to evaluate either of the cases here. I think in JavaScript 0, empty string or null is false. Everything else is true. Yeah, maybe. Remember. Empty string should be false. Yeah. The empty list is true. Yeah. Maybe. But I don't want that logic. No, that's weird. That's weird. Okay, is there any other fails? Print expected as string. Yes, yes, yes. Let's do this. Error. Error. But now I need the span. This is a native one. Oh, I should be able to know. I should be able to track the caller, right? So when I call a function, I need to know where the function was called from, right? So I think a native function, should be just not just a value into value, right? It's also should be where am I calling it from. So caller is a span, I think. I think caller is a span. In addition to this. Function caller. 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 Like this. Okay, so now I will return the error at the caller site, right? And then this should not always return a unit, by the way. Wait, no, it returns a unit here. I mean, actually, like, if I try to print something that's not a string, I can still return the unit from the print. I don't need to return the error. But if I try to generate a random thing, the if-when statement seems sort of like the match statement or the case statement. Yes. So what? I mean, if is just a special case of a match. Yeah. Yeah. I don't have matches yet. Made the if only. RNG expected int 32. What should I return though here? We have our options. The RNG function can return 0, or it can return an error. There's two options here. Let's return error. If I try int 32 to string, and we have something that is not an integer, expected an int. I'm going to return the error too. Okay, then there is also this fail. Trying to assign to a non-existing symbol. If I'm trying to assign to a non-existing symbol, I am going to do what? Wait, how does it even work right now in the compiler? If I'm trying to compile an assignee, which is a simple token. I have an assignee. Oh, it says find binding right now. This is actually going to panic, right? This is going to throw an exception. Oh no, it's not going to throw an exception. Like this inside of it is going to invent a thing. Yeah. Yeah, so it's fine then. It's fine then. I just say that over here we say error assigned to existing name symbol. What should be the thing assigned to existing name symbol? Symbol itself doesn't have like the thing, right? So this should have a span as an argument so that I can report the error correctly. Hello, bad cop. How you doing? So, and then this should return this should basically say symbol map find opt some value. I'm just going to do like the same thing as over there. Scope locals. I'm going to insert it into the current scope.
Hello, Kashanks.
Hello, Kashanks. Went to the dentist yesterday. Do they have those in Russia? The dentists, of course. I should go to a dentist one day. But I'm too busy, I'm building cast. Alright. Function application is partial. Span. Scope assigned to existing span over here should be span is assignee data span. There we go. Okay. So function implementation should track the caller. So this should just be caller, which is expression data span. Okay, good, good, good. What else? What else? What is this? This is implementation of the binary operator, which needs to have the caller. And then the span expected a tuple should be not this span, but the caller span. Binary operator expected a tuple. Binary operator name expected a tuple. There we go. Okay, success. It says success. Success means that we're going to succeed. If I try to run this, right? No, it still crashes because we have the unhandled interpreter error, right? That makes sense. If I have the unhandled interpreter error, we need to handle it in main over here. Similar to all the other things. Cast interpreter, cast interpreter error. And similarly to that, in the compiler, in the language server, to store the diagnostics processing over here. Diagnostics is this. All right. Yep. Okay. Where's Nertzel? Is lurking. What do you need Nertzel for? Are you guys working on some secret project together or something? So I'm just going to copy paste this for now. This is bad. We copy pasta, but it's fine. Yeah, it's fine. This is totally fine. Okay, there you go. Look at this. We have a bunch of errors and then we just successfully exit. So first, we failed the type check when compiling this thing. We say that we expected this to return a string because I have type ascription here, but it actually returned an integer, right? And then I'm trying to print the guest at runtime, right? So over here, I try to call this print, but the guest is actually not a string, despite this type annotation. It actually is an integer. So we fail at runtime, saying that this was expected to be a string. And then this doesn't type check because print is expected to take the string as an argument, and it also fails at runtime at the same place. Okay. This actually works. I was trying to ask you, Nertzel, how do you know that Rocklang supports the same thing? Because I went to the Rocklang and it just failed. Like, look at this. If I say 2 plus 1 to 3, like, it actually is failing, right? Do I need to, like, do something so that it continues after the error? We're making blink slider. You just type rock run over here, or do I need to like do it locally? Wait, run just didn't do anything. This is no errors. Okay, maybe you mean like locally like this. X run, X packages, rock. Is there a rock? In the next packages, rock. Who's run? Rock line. Is it not in the next packages really? There's probably like I mean, these guys probably have a Nix flake in the repository, right? I knew it. I knew it. I knew that they would have it. Have you actually written Rock, Nordsoul? Is Rock a good language? Like, why do I even write OCaml? Should we rewrite everything from scratch again? So just say nix run github rock lang rock. Like 2 years ago. Rock or cock? No, rock. Rock is different. It's not cock. It didn't have traits back then. Now it probably has it, right? You have traits? Tutorial. AI docs. We have experimental AI-friendly text files. What is the... what? Does it mean that they have generated docs by using AI? Those are advertised as Elm for all platforms, and Elm is very basic. Yeah. Wait, does Elm even have the type classes, the traits? Rewriting Haskell? Haskell is compiling even slower than Rust, so no. But Rocklang is advertised as being like fast. I mean, you say like Elm is basic, but OCaml is also pretty basic. Which one? I mean, I guess OCaml is more advanced than Elm, but I don't know. All right, I'm not going to rewrite. Rock is very fast to compile. I mean, yeah. Is it faster than OCaml though? What's faster to compile? Camel or Rock? For now, OCaml. We're talking sub-second or a few seconds for most real-world stuff. Okay, okay. Let's just see. Let's just see here. Dune clean and Dune build. How much time does it take to build my project right now from scratch? It takes 8.13 seconds. Oh, wait. How do you read this again? Was this 30 seconds? This was not 30 seconds, was it? If you want to compile fast, then you don't compile. I mean, I understand, yeah. Why does it say 29 seconds? Because of multi-threading or something? It's like combined CPU time of the user. Which one is the real time here? This one, 9 seconds total? I guess. Okay. I'm wondering, like, if... yeah, I think total. I mean, 9 seconds is pretty slow, I would say. Like, we can see... Let's say that I change... Let's say that I change here something in the like as the standard library here, right? Like this. Say like space and this. Module log 2. Module log. Nah, it's like recompiling pretty fast here. Yeah, I don't know. Yeah, I think it was worth it. But this is like very far from being completed. So if it's right now 9 seconds, I imagine it's going to be like a minute at some point. You want to compile C++ with modules and MSVC? Wait, what? Is C++ fast? You're lying to me, that gob. Okay, so this works, right? This works. Do I even have failures anywhere anymore? Let's just find everywhere the fail. There are failures in some places. There is a fail to do here. Yeah. Just say error. Folder. Yes. Function caller. Make bin up. Color into this. Color is span. Color. Okay. There are more. Embedded standard library. I think that is fine. The formatter is fine. Highlighter is fine. Maybe. I'm not actually lying. That's the messed up part. Wait, what? There's no way. To do await inferred. I mean, that's a to do. Compile faster. I mean, faster, but not fast. Faster in C++ is still slow, right? The only compiler with full support is in SVC. Right. These fails are different. Yep. Maybe we can just like see parser was. Oh yeah, this is just tests. I don't care about that. Fail expected syntax. That's fine. Yeah, like the rule parsing is failing. And not being error resilient. But yeah, it's fine mostly. Yeah, the unwrap here. The tuples is probably used in places. All right, I think if I just find something that crashes instead of continuing, then we're just going to fix it in place. Error, resilient, interpreter. Okay, so everything is error resilient, and we can just write code, and we can still have support from the language server, right? Which is nice. Okay, like over here, I just deleted this, and then it says like that, like something. Now this is unexpected, but I still have parsed print and shit. Okay, like I think that's nice. I think that is nice. Guest is could not find guest. All right, makes sense. Guest is this. How about we try to write the guessing number game then? Actually, because this is not the guessing number game yet, right? How about, let's say print the number. I mean, we just need to implement some more features of the language for that to work, right? The number has been guessed. Right? Let's just run. Guess a number. Number has been guessed. Then we are going to try to read. Right? So I want something like stdio input. Should this be in the prelude? I don't know. I'm not sure even if the print should be in the prelude. But sure. Wait, can I not go to the definition of this? Oh, wait, I cannot go to the definition of this std, but I can go to this one. By the way, I cannot go to the dots. So like this doesn't work. Go to definition. I can only go to the std, which opens this file right now. It's like, yeah, that could be also improved. Input is IO. But this over here is wrong. Okay, so I actually crash here. Why? Because we have exception not found. Okay. Evaluate the const expression. Map find. I hate the fact that this doesn't give me the full stack trace. This sucks. But I mean, this thing, the IO doesn't have the input field, right? So this doesn't compile and it crashes. It crashes what? Exception not found. While compiling, not while evaluating, right? Field input is not there. Wait, hold on. We have compiler error. Field input is not there. Idle error exception not found. Maybe it's when I actually... Yeah, no, it is when I'm evaluating it. Yeah. Like, why is this... How can I make the stack traces of OCaml actually point me to the line that actually makes sense? It's because when I have the expression dot expression field, right? This one, right? Yeah. We have get named. This one, get named. This can fail. So I should actually get name opt here to make it fail. Make it resilient. Match this with some field. Then I just return the field. But if it's none, then we're going to say error data span no field field this doesn't exist, and then we return the shape is value per. This needs to be in parentheses. Okay, yeah, there you go. Now we have this standard library. Maybe I can work on the standard library now. Yeah, see, like input is error, right? This is error because this doesn't actually exist. Although what's weird is that, like, yeah, it's reporting the diagnostics in the wrong file right now. Which is fine. I'll fix that at some point. Let's ignore that. So we want the IO. Have the thing that is called input. So input should be the string string, which is the prompt, and returns me a string. Just reads a line like in Python, right? Native input. All this IO print and IO input. I don't know. Input, whatever. Let's see. Okay. So there is now no native input. Which means that I need to have the natives, which is the input. There's a print. Input is a function. Input expected a string. So what do? I just do like print f. This. And then how do I read line in a camel? Camel read line. How to read line REPL style in camel. Oh, sorry. And to flash it, too. Flash std out. I mean, basically we print string s and flash std out. Your activate Linux text is kind of small. I think you should make it 10 times bigger. I can't control it. It's you know, it's like to change the size you need to activate first, I would guess. Lush. Just read line, right? Let's just like read line. Yeah, there is just read line. Okay. Just read line. Okay. That is a read line. Shape is the string and this returns shape is the error. Let's try now. Type checking failed. Yeah, type checking failed. That's right, because over here I copy pasted. It should be a string as an argument and a string as the result. Okay, the number has been guessed. Let's see. Restart language server. So can I now say, so input, right? Input is string into string. No, we should say that let line be the line, it should be input, yes, like this, right? There you go. Now this is a string. And then we need to convert the string into, so this is my my input, right? My input is this. Yes. And then I would say yes is. So I want to convert a string to int32. That's right. Let's do that. So similar to this function, just the other way around. String to int32. Okay. I have a feeling that the language is like almost usable now because of this like stuff. Now it says there is no native string to string. No, string to int32. Yeah. This one technically should potentially fail, right? With yeah, something like that could happen here. Because the parsing can fail. Not exactly. This is not implemented yet. This is being ignored. So we go back to natives, and I say similar to int to string, we say string to int32, which is taking this string, returning int32, and it says we have a string to int32 expected a string. If we have a string s, then I'm going to say let value be int32 dot of string. There is of string opt, right? String opt is going to, yeah, just like if there is a failure, there's none. Yeah. Let's do that. Of string opt as. We're going to match this with, if it's none, then it's going to be error, right? We're going to error at the caller. So this is a value shape. This is going to say that would not parse int32 as something like that. And then if it was parsed successfully, then we return an int32 value, right? Like this. Okay. Okay, guess 1, 2, 3. Nice. That seems to work. Restart language server. Okay. Why is there type check failed? String is not int32. Wait, what? Where? I think this is in the incorrect place. Type check failed is actually over here, right? Because okay. Because string to int32 is string into int32. There we go. I need to like fix my reporting of the errors. Be in correct places. All right. So we have that. And now I have guessed string to int32, right? And we're going to say if. We're going to say if. So now I want the comparison operators, right? I don't really want the operators, really. I feel like I want the macros at this point. I feel like I want a macro at this point. So let's also do something like this. Let's start with a different macro than the operator. I'm just going to say that guess is input into std string to int32 like this, right? That's what I want. So this is not inferred, and then this says that there is no syntax for the pipe, right? And this one should actually not be core, because this should be implemented through the macro system. Let me first like commit this. Yes, and number progress. And then we're going to do that. So how do you implement the macros, right? So so this thing, actually I still have the syntax rules to be kind of special case. They are not part of the standard library still. Right? This should be part of the standard library. And then we have this. This should be the syntax for the pipe. This should be the syntax for the pipe. Which is not core anymore, right? So this should map to a macro. And a macro is a function that takes ASTs and returns a new AST. Right. This should be relatively simple. We'll have the argument and the function as the arguments there. Okay. And implement the macro. Is Badcop trying to sell a bad programming language here? What's going on? Have you completely stopped writing C++ yourself very much? Okay, let's just implement macros real quick. I need a couple more features though. So it's supposed to be in the standard library. In the standard library somewhere. I mean, technically, just like just over here, probably, since this is where I define the syntax. Since this is where I define the syntax, I probably want it to be implemented here. So I want to implement syntax pipe as no to be equal to the macro, which takes the function, taking function and argument. Well, I mean, it will pipe the argument into the function, and we return the AST, which is basically, so we need to make sure that we first calculate the function. So function is function. No, we need to first calculate the argument, right? Is argument, and function is function, and then we call function with argument like this. Okay, so this is how it's supposed to be done. We have macros. This is an AST, and this is an AST, right? This is a quote macro which generates AST. This is unquote. And speaking about unquote, I was also thinking that this dollar sign should be instead of a backslash. You guys like the backslash? Because the backslash is like an escape symbol. Like when we do, this is very similar to like string interpolation. A lot of languages, when do the string interpolation, they are doing the dollars. Because that's what Bash has been doing. Like the dollars, they like, where does the dollar sign even coming from? It's coming from Bash, isn't it? I just had janky audio. It comes from the US currency, I think. So why is it used for interpolation then? Why do most languages use dollar for interpolation? Because this is greedy gremlin of the syntax. It's short, distinct. Shells did it first. I knew it. Ruby has a hashtag here. Really? I feel like just the backslash is like the just makes sense. It's an escape, right? Like we escape the slash and to do the new line, right? But if I say like if I have a string which says like escape and then over here some expression, this is an escaped expression inside. Sin has hashtag too. So this is technically similar to this sin, not sin quote. You're talking about quote, not sin. Sin is for parsing. Quote is for generating. This is the quote, literally. Another question: why string interpolation called interpolation? Why is string interpolation even called interpolation? Because some academic centuries ago, someone decided that it needs to sound like math poetry instead of what it really is. String snickery. Okay. Yeah. You're not sure? Do you like the dollar? Do you like the dollar? How do you set up your ChatGPT to talk based? There's settings that you can set for your ChatGPT, right? Do you think dollar? I mean, dollar is something that I'm used to. There's also this also is basically resembling the Lisp, right? in Lisp they have quote, and the unquote is actually the comma. For some reason they have the comma. I don't know why, but Lisp is weird. You mean I like dollar? I don't think I like hashtag. Hashtag, I'm using hashtags for comments right now, by the way. Which I'm not sure that I like that, but that's what I do. So I don't know. I feel like I want to change it. But I don't know. Does backslash make sense? Looks a little weird. Maybe I will be used to it though. What if I do I need parentheses, or like is it fine if I just do it like that? Like this is not interpreting the backslash quote is not interpreting the thing. If it was, it would close the string. Well, backslash is not about interpreting. Backslash is about escaping the string. So I'm no longer writing, like backslash is for special things, basically, right? And one of the special things is that arg needs to be to interpret the arg. Yes. This needs to do that. But I mean, it would make like backslash is a special thing. I feel like because of that, because of what you're saying, we like it would make more sense maybe if we had the parentheses here, which are required. So like backslash and then inside the parentheses, the interpreted thing. So backslash and the parentheses makes it like right, because how do I differentiate between the slash n and the n which should be interpreted, right? Then we should have we can have a like slash n and slash n like this, you know? Not fully sold. Yeah, I don't know. Slash is the poor man's lambda symbol. Yes, there's also this. Although I don't even use the lambda symbol, right? I'm doing this the JavaScript way right now, where the I'm just using the fat arrow, so I don't need the lambda. I just say let function, right? Like this over here. This is technically a lambda. The macro is not even needed here. This is the argument. This is the body of the function. I think if you would use backslash, you cannot go without parentheses. Yes. But I mean, I can go without parentheses when doing this. So like, I want to use the same syntax kind of when doing string interpolation and AST interpolation. This over here is the quote operator. This is generating the AST for the macros, right? So this over here is easier. This can be interpreted without parentheses, because we are going to have basically what we're going to have syntax quote, right? Syntax quote. Syntax quote is a quote mark, and then an opening bracket, and then the thing, and then the closing bracket, like this. And then we can also do this for formatting reasons. And then this can be of any priority. And then we do that. Okay. I still don't really like the fact that I'm including the formatting in the definition of the syntax sometimes. So we have quote, and then we will also have the unquote. So so unquote is doing the interpolation, right? So it is just, so previously it was a $, and then some expression, right? But I can just make it a backslash, and because it is like of the highest priority, this can only be the an identifier, or it must be something inside parentheses. But if I do the interpolation inside of a string, then yes. Then I must have the parentheses there. Or I can like just so that it's consistent inside of a string and inside the AST interpolation, I can require the parentheses always. Maybe it actually makes sense to require the parentheses always. I don't know. Let's just require them always. See if I like it or not. So we have quote and we have unquote. So this should be actually parsed successfully already, right? Let's have example, custom syntax. Implementation of the syntax is not there yet though. But this over here should work, right? I need to include this in the workspace. No. Option is none. Where? Parts lines. Down, down. Oh, because like yeah, okay, yeah. Um. Maybe I can ignore. Prefix. Oh wait, no, it's not even like going to work like that. Like I need to not do this. This is like I'm special casing my rules right now. Let's remove this from here. Let's move it somewhere in the standard library. Let's actually have the standard syntax KS here. I will have it here, and then in the standard library, I will just include the syntax for now. This is just going to be interpreted. Yeah, so impl syntax should be a thing. What if there is no /n and instead we go full Unicode, reinvent the wheel in a time where Unicode is everywhere, free the body and the soul from the ASCII US oppression. Also, my keyword can easily type it's called the paragraph sign, I think, so we could do this. That US people can finally get to know how it feels when you get carpal tunnel because of their convention. I'm gonna try sticking to the backslash. If I don't like it, I might revert back to the $sign. Because $sign is like is used in other languages, so like it kind of makes sense. I just think maybe it doesn't make sense. I'm not 100% convinced yet. Yeah, I'm not. I'm not going to use the Unicode though. No, I'm not. You can though change and implement your own syntax which uses the Unicode. You want that, of course. I do not have. Wait, do I? No, I do not. Hashtag also looks good as in Ruby. Yeah, but I don't know. I feel like hashtag is more rare. The $sign is more obvious. There is also the choice of not using any symbol and just using curly brackets. Currently I don't use curly brackets for anything. This is what Python uses, for example, right? We just do the interpolation inside the curly brackets, you know, like this. And Rust also does that, right? But Rust uses curly brackets for other things. I cannot really do this because like this should be basically valid syntax. If I like I need to not use curly braces in other places for this to work. You know, will Rust ever get a proper string interpolation? I think you can do it yourself now with macros, with proc macros. Like I think you can do format foo 1+1 in using your own procedural macro. All right. It just doesn't do it in the standard library for probably like backwards compatibility or something. I'm actually not sure why. I'm not sure why. It's not because of backward compatibility, because they're not even allowing that to be parsed, right? If you do print line string +2. If you want to say invalid string, right? Yeah. It's just trying to see there just an identifier. It's not even trying to parse this right now. But it could. I mean, technically, when let me think about it a little more. Then, when I'm doing the AST interpolation, this is easy because this is technically valid AST itself, right? But what about the string interpolation? When I see a string, when I see a string hello, and then we see over here, you know, world, right? Like this. This over here. Should this like what should the lexer say about this is the question, right? What should the lexer say? And I think that for this to be better, we should like I should not invoke the lexer on a part of the string at runtime. I think the lexer should support this thing basically. Yeah, I'm wondering how Python is doing that. Because Python, like, because you can have like over here inside of this, you can have any expression, and then you can have another like string inside, basically, right? And then inside of this string, you can also have like another interpolation, you know? This works in Python with format strings. Because they would have to allow format foo impl display a default. Yeah, but what's the problem? There should be like any expression should be possible there, right? Is what I'm saying. Like, why would that cause havoc? Like, people would not just use that. Like, if you allow something to happen, I don't know. How is that a bad thing? All right, expected rule priority. So, like, what do I do here? Impl syntax. This should. Okay, serious question. Can cast support strings with different opening and closing symbol for nesting? Because that really bugs me with strings. Not yet, but we should. I think OCaml does something like that. Maybe we could call clone OCaml. Here's the lexing of OCaml. String literals. Yes, you can do this. You can have a quoted string ID. Over here, look at this. Look at this over here. Quoted string. You open a curly bracket and then a vertical bar. And then you end the string like this. Wait, what is this? Nested axt hello. Axt. So we have a world inside of this thing. Oh, like, oh, this over here is the beginning of the string. This is the beginning of the string. This is the end of the string. So this, so the text itself is hello world, which has like a nested thing like that. This is C++ raw strings. C++ raw strings. Raw string literals. I mean, you have that in Rust, right? It's similar to the Rust one, just without the hashtag. In Rust, you can only do a series of hashtags, not an arbitrary string. Yeah. Do you want arbitrary string? What is the reason for the arbitrary strings in C++, though? Does it just act as a separator? Oh, I need to implement this. Making macros. And to do this, implement syntax. So there should be syntax for implementing syntax, basically. That's what it means. Yes. Somewhere. Syntax. Core implement syntax is going to be implement syntax. Implement syntax name is equal to the implementation, like this. Is it going to parse now? There we go. Now it parses. Right. The formatting fails still, though. Why does it fail? Cast parse examples. This is standard standard syntax, right? Because I have a comma. Oh, because this dot doesn't work. All right, yeah. Because this over here is the pattern for the argument. Because I never implemented the tuples yet. Yeah. So we have a comma, trailing comma, and then I need to have another syntax. Which should be somewhere. Function type ascribe. I don't know where. Syntax core. Field. So this is like a field. But not like get field. But field initializer. I don't know. What did I call it before? From understanding, the limitation is because the way you can put a token that is impossible to appear in front and the end, whereas in Rust you cannot put a raw string that may contain arbitrary chains of hashtags inside of it. Not sure, not sure. We should have some solution for that for sure, but I didn't really think about it much. Old Rust version. Standard. Syntax. This was called macro field. What about the other dot then? What about object dot field? Oh, this is field access, and this one was just field. Okay, that's why. Sure. Let's call this field initialization. Yeah. I'm not sure what the priority should be. Maybe 6. I should probably copy the previous ones though. We'll do it from scratch. Rep ever is. So we have a field. So a field is basically a dot followed by the label, right? And yeah, and then we optionally make it equal. So value is optionally making it equal. What about this expression colon type? That's like the same. No, there is always a dot. Yeah, there's always a dot. That's fine. So we have label, and then value is an optional equal to the value, like this. And then there should also be all of optional type, I think, before that. Even though this is going to parse. Yeah, I think so. So type is optional. Colon this. Optional group should have a keyword as the first part. And we have a space here. Yeah, that makes sense because this should actually, yeah, this should actually not trigger the error because it's white space. White space should be ignored. So expected keyword is match group parts. I feel like this should be a group rule parts into list find map function like this, right? Rule syntax rule keyword. This should return some keyword, and then this let's do option get here. Field access has this, but was expected of rule part list. Wait, what? Camel's error messages are not that good, I think. Index rule part is not compatible with syntax rule part list. Because I don't need this. Okay, so if I see the syntax rule white space, Then I just ignore this. The other ones are going to actually panic though. Okay, I think that should work. Okay, nice, nice. So this has been parsed successfully. There we go. This has been parsed. We can format this. This is formatted automatically. Nice. Nice. All right. This over here missing the space on the impl syntax. Impl syntax. Syntax, space, and then name. Yep, there you go. Okay, so this doesn't compile though. Obviously. If I try cast run, guess a number. So now there is no core syntax for impl syntax, right? This over here cannot do it, so we need to have the impl syntax. There you go. Let's do it. Parser, compiler, for syntax. Okay, so we need to be able to implement syntax. So implement syntax is a core syntax. It allows us to implement the syntax. So impl syntax has the name and the implementation, right? So I say that name implementation is children. We get name and we get implementation. Okay. This is unnamed too. Compile. All right. So now I'm just going to evaluate the name. I'm going to evaluate the name. The type of this should be string. This is a little bit different than what I was doing before. So we evaluate and then we say value expect string. Oh wait, so these things are actually going to panic because we expected string got something else. Yeah. Okay, whatever. Expression has a type value, type expression, expression type value. Yes. Name and name expression. This and then name is name. You expect string. Then we have the same. Implementation is also going to be evaluated at compile time. Implementation. Implementation type is going to be although something else. I'm going to say new not invert here for now, but to do the syntax highlighting of a camel also doesn't work. Beautiful. Fine. Okay, so and the implementation is not a string. So implementation is supposed to be a function that operates on ASTs, right? I had a dedicated macro type before that. I'm wondering if the macro type is actually needed, because this is literally just a function, and I should be able to just call it like a function. I feel like this time I'm going to try making it without the special type for macros, and just have it be a function. We'll see. So I want to expect a function here. Expect a function should be value into value function like this. It's def captured, yeah, sure. The function expected function. Okay, should we do that? This must be an expression. If I'm going to do the other inside of this place, actually. The expression itself is going to be just a unit. There is no constructor unit. Constant. Unit. Is that what you want? Okay, and then we have the evaluated expressions, which is the name expression and expression like this. So now I have the name, I have the implementation, right? I need to basically assign the implementation to the name. So I need to find the syntax rule with the given name. That's a little different than before, but sure. So we have the current syntax rules, or do I? I actually don't have the stored current syntax rules anywhere, because I have already parsed the thing. Yeah. That makes sense. Let me just do for now in the default, because I'm using the default. Probably. Cast default syntax rule set. So I need to find the rule. Syntax rule set. Syntax, no, it's not syntax, right? It's like parser. Parser rule set, find rule by the given name. Right, so now I have the rule. And I need to just have this rule be associated with this implementation. The rules though. The rule is just this thing. Have spans. Shouldn't I have like an ID here or something on the rules? Shouldn't I have an ID there or something? So when I parse a rule, I just generate the new rule. A new ID. This is not an if, by the way. This is success. That's not success yet. There's no core syntax field in it. Yeah, I mean, I'm trying. We're going to make progress. We're going to need to have the field initialization too. Yeah. Constant. Yeah, so basically the compiler, we have the compiler. The compiler will hold the rules for the things. So compiler state is going to know what are the custom syntax implementations. It's going to be a hash map. It's going to be a hash table because it's going to be mutable, I guess, from the ID into, so like ID of the syntax rule into the implementation. And the implementation is just going to be a value. Which is expected to be a function. Value function, like this. Which is not being exported, by the way. From the cast types. Wait, do I have something like, I don't know, value function? Do that. Oh, it's a shape. You know what? Let's just store a value there. Don't care. For now. So when I initialize, I will say that custom syntax impulse is hash table create. Right? And then when I enter scope, the custom syntax implementations are the same as the original ones. Because it's like global thing. What is this? Default? Wait, is this function even being used? It's not. Let's remove it. Custom syntax implementations, hash table, create. Unbound record field. State blank. Oh wait, there was, wait, what? State blank was used. You lied to me. Okay, it's fine. And then when I initialize the compiler, it's the same thing. Okay, fine. What? And this is what? This is default. Is this being used somewhere? Compiler. Maybe this one is not being used. I can remove this one. Oh, it is. Never mind. Used underneath. Syntax impulse, hash table, create 0. Okay, success. Yeah, that's not really a success yet. We have core syntax, impulse syntax, right? So we have this rule, and I'm going to say compiler state custom syntax implementations, and I'm going to hash table add to this thing. I'm going to add to the rule ID. I'm going to add the implementation, and I'm not even going to expect a function there, right? We're just going to do this. We're going to use the inferred type here instead. Yeah, there we go. So we added this. Now that we have the custom syntax implementation associated, we're going to use it in another place. But before that, But before that, I need to implement the other syntaxes, which is the syntax for the core field init and quote and unquote. Right? So we need a field init, we need quote, and we need unquote. Unquote should actually be part of the quote, so it's not going to be used outside. All right. See this? Field initialization. Field initialization can be both a type expression, assign a pattern, but for now over here I technically only need the pattern. So let's just do error span to do it error find. Right, so I'm going to have the pattern. This is not inbuilt syntax. This is, and I mean, this should just be to do. Where? Kind of. Where's my syntax highlighting of a camel? Why is this not highlighted? Hello? Is this too big of a file now or something? It's just 1,000 lines. Why does this not highlight? Weird. Stupid language. Build in it. Quote. Quote is going to have to be the expression. The underscore here. I mean, maybe eventually we'll have the patterns which are quotes to pattern match the ASTs. Right? So this is now going to say to do over here. Now I kind of don't have the where the to do is. I can say to do percent as lock, which is going to show me the file where it's not implemented. There you go. Yeah, so I'm trying to have a pattern which is the field initialization. Where did the IT guy go? He probably ran somewhere. Nice. Welcome, Veldek. Give me more. More. Yeah, actually we need to... Wait, do you have the syntax comma? Syntax comma, comma implementation. Pattern to do comma pattern. Yeah. Wait. Do you have a to do comma pattern or something? Why does it say this? I'm trying to field in it. Over here. Is it because of the different priorities? Oh. Is it trying to say that this is an expression instead of a pattern? This is supposed to be a pattern because this is a function, right? This is a comma. Oh, it's because is the comma is trying to actually, yeah, the comma should also be compiled as comma implementation. Let me see here. We need to collect the list of the core comma. Children is this. Compile the kind. Child. Wait, what? Yeah, we have the children already collected here. Okay, whatever. No, not whatever. Like I need to basically I need to have the pattern which is a tuple, which I don't have yet. Let's have a pattern tuple. Pattern tuple is going to be pattern tuple, and pattern tuple is a tuple which is a tuple of patterns. Like this. That's what I want. Okay. Have pattern tuple. And we need to match tuple. Tuple print pattern. Okay. What else? Pattern match. Pattern match tuple. Tuple is a tuple pattern. And then, so if we have a tuple pattern, then we must have the value which is a tuple, right? So I'm going to match value shape with. If it is anything else, then we are going to error. Expected tuple got this value, print value, return turn. So like, I guess I don't actually match anything in this case, right? I need a span. And the span, which is going to be pattern data span. Okay, and then if this over here is actually a value tuple, then we're going to say tuple.zip order A. Zip order A tuple, B tuple. So tuple pattern and tuple, right? And then we're going to say tuple dot let's have iterate function field pattern and field value. I should not even like. Do I have fold? I mean, I guess I can have two sequence. So we have sequence, and then we're going to say sequence fold. So we want to fold the sequence. Function, which has like the accumulator. We are going to start accumulating with scope locals empty. Scope locals, what do we have? We have empty. It's a symbol map. Symbol map empty. By symbol is this. And we fold left this sequence. All right. This function is type unit. Yeah, because this should not be unit. It should return the accumulator. This is a symbol map, so I'm going to. So we need to find the inner matches. So field matches is a pattern match. So we have a recursive pattern matching now. We need to recursively pattern match the value, which is field value, with a field pattern. And then I need to say symbol map union. So I need to have a union of the character accumulator and the new field matches using function symbol AB This should actually like fail because we're not supposed to have the same name twice. I'm going to say fail here. I mean, let's just keep the last one, for example. But before that, I'm going to say error. Um, multiple bindings of same symbol. Print symbol. Span is data span field matches dot by this expression has type tuple member and this right, because I don't care about the member itself. Here, right? Like this. There you go. Next. Compiler. Inject pattern bindings. If we have a pattern which is a tuple, then I just need to tuple to sequence iterate function member and field pattern. I'm just going to inject binding. No, going to inject. This is also recursive. Inject pattern bindings of the field pattern. Right? Okay, then what? Compiler initialization. What's the type of the pattern which is a tuple? The type of this is going to be a tuple type. Where every field is going to be mapped from so we have a field pattern. We're going to say field pattern data type, right? There's type a list, but it was question of type tuple. It's not list, it's tuple map, right? Field pattern is pattern data unbound record because our camel is stupid. This is pattern. Thank you. Okay, next. Now we have the LSP hover pattern tuple. Pattern tuple. I'll need to hover this what option. Tuple to sequence find map. Find map function member and field pattern. This is going to be hover pattern field pattern. No? Version has type position. Oh, we need position to position. Okay. And then we have the inlay hints for pattern tuple. I don't want the inlay hint for this. And then we're going to have tuple sequence flat map function member field pattern into inlay hints of pattern field pattern. Okay, now we compile. Let's see what's going to be next. Now we have to do over here, right? So when I have the field initialization, it still is the same error. We're going to say that this is a pattern tuple with a single field. It's a tuple with a single field. Right? So field init, I need to also like get all of the children here. So field has a what? What did I do there in the syntax rules? Field init, we have a label, type, and value. Label is children, tuple, get named label, ast child expect ast. Type is children. Tuple get named opt. Type ast child expect group. Option action type into expect group and group dot children tuple ref single unnamed child expect ast. Something like that. Is that what I write? So type is on optional ast. Yeah, that's what we want. We have this, and then we have also the value. I'm going to ignore the type and value though for now, because I'm just doing a pattern. Yeah, I don't need that. I'm just going to say that the tuple is a tuple of a single thing. So tuple make the single one which has a name. And the name must be label must be an identifier here for now, right? Yeah. So I'm going to say that label is match label shape. If it is an identifier, it should be identifier name. Otherwise, I'm going to say error. Span. No. Label span. Field label must be identifier. And then I just return. And then I just return. Make initialize error span. Kind. I hate this. What do you mean? Expression was type of type A. This should return A. Bro. The expression has type span into a compiled count into a. Where? Where does it have this type? Function application is partial. Maybe some arguments are missing. Which function application? Which specific one? Return, because this needs to be like that because of different priority. Okay. The variable expression has type as the shape. St shape has no identifier. Yeah, st should be as simple. Should be as simple. Where token is identifier. Like this. Where token is this, where shape is that. Right? There we go. So we have a single named field with a label being its name, and the value is going to be so this one actually depends on the value, right? So value is going to be a pattern. In this case, the value is value option map or it's going to be match value with some value. Then I'm going to compile pattern with using this value, right? But if it's none, then I'm going to initialize it as a binding. So pattern binding with the same name, right? Yes. So name is an initialize pattern using value span. So name is going to be symbol create label. Type is type. Let me just say here that type is type not inferred. But we will have a to do here. We actually parse this type. We have type. We also have references. What else? Span. Span is just here. Yeah. Yeah. Okay. Does this work? Now we have the comma pattern. Okay, that makes sense. So comma pattern should consist of these ones actually. So this is the field initialization. This should actually still be like a comma. Implement a comma impl. This should still be comma impl, yeah. Right? Yeah, and this is like for all of my children. Every child is this. Be like with a comma impl. Module C kind AST. I don't care about this. Okay. I'm going to move this to another place. Cover impl. Yeah, so children is map. I'm just compiling the child here, right? But we are going to see if the child is actually a thing. I need a helper method here. Let field tuple field is that. So tuple field should have yeah, type A, Visual C compiler, kind is a compiled kind. So this should return like a label for the field, right? So string, and the value of the field, which is A. Yes, that makes sense. And the AST and children. Like it's kind of all of these arguments need there. But it returns not A, it returns string and A. Like that. Okay, so in this case, I don't initialize this yet. I just return label and value here. Yeah, and this over here, this says return init error. This should not return init error. This should raise exception. Exception. I don't know, invalid argument, whatever. Invalid argument. Field. Expression has type A, but oh yeah, this should not be A, this should be a string and A. The expression has type, yeah, and I don't actually return, I actually throw here now. But I will catch it, but I need it with return technically, I think. Okay, and instead of initializing the error over here, we're just going to say invalid arg for now. Okay. So over here, I have a child. I have a child. And child should be dependent. And over here, when I have a pattern, which is a comma, this should return pattern tuple, initialize pattern, where this is children. Yeah, yes. So we have child is compiled, right? But I'm going to match the child. I'm going to match child shape with so if it's anything else, then we do that. But child is st. If this is a complex node where we have rule and everything else, right? So rule, I want the rule name to be, I want the rule name to be core field initialization. Do I have the field initialization? Then this is going to be instead the field. Oh, but these are the children. Okay, now, yeah. The children are different. The children are different. This was expecting only the unnamed children. Now we have both unnamed and named, right? So if it is a field, then it's going to be a named one. Let's iterate and let's say that instead we say that unnamed children is a reference and named children is a reference, like this. So over here I'm compiling and I'm going to say that children is this one, and then we add the children, unnamed children. In This over here is named basically, so we need to say that name and value is tuple field, right? Module C, kind, child, and children, and what's the argument there? AST group. Rule is this. I guess root is what I need here. So child root. This. So we have name, which is string, and this is a thing. Yeah. So we just say named children. I mean, I could just start with the tuple instead here. That tuple is a reference to tuple empty, right? Like this. And over here I say that tuple is tuple add unnamed. This one child. And we just use this tuple, and we just use this tuple. And over here we say tuple is tuple add using some name and the value. That tuple add like this, right? Okay, so tuple now needs to just be the reference like this. Cool. I think this is all. See? There's another to do, which is a quote, right? So yeah, okay. There's like other parts, right? I have made the tuple patterns. Now we need to do the actual quoting for the ASTs. I feel like I'm not ready for this. The quoting means that, like, can I do this partially? Oh, sorry. To do. Beautiful. Let's comment this. Included file is empty. Yeah, that's fine. Okay, let's try something. Let's try something like, just make sure that my thing is working with the patterns and tuples and stuff. So what I did is we can now have a function which takes a tuple of like A and B and returns, I don't know, like, and like does something with them. I don't know. Print A and use std prelude. That, okay, sure. I could not find A to do. Oh, wait. Oh, I need to restart the cast language server though. Right? Yeah, there we go. Look at this. This is already working. So we know that A is a string. Why? Because I have printed it, which means that A is a string, right? B is unknown still, right? Because I am not using this as a field. Okay, nice. So F is a function that takes B and A. I'm doing this in the reverse order, which is incorrect too, by the way. So yeah, why did I do this in reverse order? For some reason. Comma, impl. Over here, this should not be reversed. Right, there we go. So we have a function which takes A, which is a string, and B, which is unknown yet. And if I say like something like print print std int32 to string b, then it's going to be known now that b is actually an int32. Why is the inlay hint is not shown here though? Or do the inlay hints, they just stop showing if the if it's like too far on the right? Is that how VS Code works? Because I definitely have inferred this, right? And even the string here is not shown fully. Is it because the line is too long at this point? Weird. But yeah, now we know that the function f is a function that takes a named field A and a named field B. And we can also have the unnamed, right? Like I can have unnamed x, right? So now this is a combination of a named and unnamed field. We can do that now, right? Print x2, and this first name is now string. All right, this is working actually really nicely. Let me just commit this because this was huge. Tuples with named fields, and then we're going to work on the syntax, and we will have the macro shortly then. So the only thing that is missing is me implementing the quoting, right? So this means that I need to have a new type. This means that I need to have a new type. Syntax, past types. We need to have a new type, which is an AST, because we are going to have the ASTs as first class value now. So we have a type AST, and we will have a value AST. So, and value AST is going to have just AST inside of it, which means that the types now depend on the cast AST, right? This working? Not value AST. Module AST. Cast AST. Okay, there we go. So I have a value which is AST and the type which is AST now. Print. I want to print the type AST, then f AST. If we want to print a value, which is AST, then we print f. AST, print AST, right? I guess. Okay. The type of value AST is AST. In the inference, we have must be the same. Okay, this is success, but we just don't have the value. So like now I'm going to introduce the way to construct an AST, which is what the core syntax quote is about in the end here, right? So syntax rules quote just has the unnamed one. Okay, good. Yeah. I'm just going to say that body is children tuple unwrap single unnamed AST child expect AST like this. So we have the body, and then this is my current to do, right? And to uncomment standard syntax this thing. Okay, yes, we have this to do over here. Doing the quote. So in order to do the quote, we just need to replace all of the things. I can do first the simple thing. No, I don't need to. We need to have a new expression too, an expression that constructs an AST. So we need to have an expression quote, basically quote AST, kind of expression quote AST. expression quote AST, a word compiler. What? So the quote expression is having the wait, how does this work? I'm just going to look at how I did it before. I mean, we just basically have the same as the AST itself, kind of we mimic the AST, but the children can be other expressions, potentially. Right, that's all. That makes sense. Just is that how I did it before? I don't know. Expression roots, substitute definition, values, hygiene. Yeah, sure. It makes sense, I guess. So we just say that the we construct the AST using the given rule, using the given syntax rule, right? And we have the oh, but now we have the parts with like quantifiers and stuff. Interesting. That's something that I didn't have in the previous implementation. Okay. So and yeah, and also inside of the AST, I'm actually storing other things now. This is more difficult now because of this is the one that I'm interested about. We have the rule and we have the root, which is a group, and a group has a rule, parts, and children. I guess I don't really care about the parts. I can make this empty for now. And we have the rule, and then we have the child tuple. Okay. We have a rule, and then we have root, which is expression quote AST group. Expression quote AST group, similar to how my AST itself is defined. So group, we have a potential index rule group. Hello, Nigel. Hello, Nigel. Parts. Like, well, I don't care about the parts here, though. We just have the children, which is child. So this would be expression quote AST child. And what's a child? Child is either AST or another group. And expression quote AST child is either group CLI command compile args cast compiler CLI args compile standalone binary. No, not yet. No, right now it compiles the intermediate representation and shows it on the thing. Well, I mean, intermediate representation is yeah, Once again, I think like my AST is basically like the CST. It's concrete syntax tree, not abstract. And my intermediate representation is probably closer to the AST in the normal terminology. But yeah, so like I'm compiling the thing that is going to be interpreted. So I'm compiling not the standalone, not yet. Standalone is going to happen not very soon. We're going to transpile first to something. What's the difference between AST and CST? CST is concrete syntax tree, which allows you to reconstruct the original code, right? And abstract is abstract. So will you like lose some information? I don't know. AST versus CST. Technically speaking, the parse tree generated by the parser is usually called the concrete syntax tree. Defining the AST separately from the CST can provide data structure which is much easier to work with for an analysis and code generation. Yeah. So like I think my ultimate representation is actually AST and my AST is CST. So, but when we say like about we talk about macros that I'm trying to do here, right? Macros usually are told to work on the ASTs, but I'm actually going to construct the CST, right? Like if you are making the proc macro in, I don't know, like you know, Camel, we also have like the proc macros, right? The PPX or stuff. So over here, I'm generating this stuff, right? And I'm generating, they call it AST builder. Even although this technically is not, like, is this actually AST? Or is this concrete syntax tree? Because I do have the locations, right? Which is, like, I guess, like, they don't store the file name here. Maybe that's the difference. Position file. Oh, wait, the position has the file name. No way. That's weird. You can start in one file name and end in a different file name. Yeah, yeah. So like, I feel like this AST is actually also able to reconstruct the source code because like you have a, like, I don't know. I guess not exactly because like the dot itself is not like there and shit. Yeah, but like, it's close. It's concrete syntax tree is basically the thing that allows you to reconstruct the source code, right? That's the definition, I think. Expression quote AST has the root, which is the AST group, and then we have the child, which is group of expression quote AST group, or it's the actual like child, or it's the actual like value AST of expression quote AST, like this. That's what I want. Okay, print. If I want to print the expression quote AST, def quote AST. I'm just going to say dot 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 here. When I want to, so this is the interesting part. When I want to evaluate the expression, this is where we are going to construct the syntax tree. Quote AST, right? Quote AST expression. So I need to And to calculate the children, quote is let's have this quote expression. Quote expression. Quote AST. Quote AST state expression shape quote AST into, so this should return AST, right? Right. So this entire expression will return a value which is AST. That. Okay. So now there's going to be quote group. Quote group as a group, which is expression shape quote AST group. And this should return AST. Don't have auto completion. AST is unbound. Module AST is cast AST. Can I say AST group? Yes, that's what I want. So then I just want to return the AST, which has a shape is complex. And span. What's the span? The span is the span of the original expression. Is what I want. There. Just have it to do here. Whatever. So this thing needs there's no field. There's a rule and then there's group. So rule is expression rule, and group is a quote group expression root, like this. So now we need to quote the group. This is root. Okay, what's this? So I need to return the group. Group has children, right? Which is group dot children, and group dot children here is a different thing. Oh no, it's not. It's a tuple. Yes. So this is a question. Quote AST child. Yeah. So it's going to be children into tuple map function. Group AST this. Can I do that? Unbound constructor group. I say function. Child. Into match child. With this. And child is expression shape. What is the child like this? Rule is group rule. Arts. It's going to be empty list for now. Expression has type expression shape quote ast child tuple, but expression must have ast child tuple. Yes, but I mean, oh, it's because okay, this should be in that. Yeah. Okay. The constructor group is except one's argument. Group. This is child group. This will return group, and this should return. This should return ast child. This returns this group, which is quote group, child group. And if it is ast child, then it's going to be quote ast. Quote ast state child. Child. Does that work? Not a child ast like this, right? Okay, there you go. It actually compiles. Okay, which means that it probably works. And when I initialize Devin's dev, hello again. Hello. Expression quote ast. Expression quote ast. Let's just say for now that the type is going to be ast. But I will say that to do assert all children are ast. I think. Okay. LSP hover. I'm going to, if I have expression quote AST, I'm going to say none. But I'm going to say to do here because I'm too lazy to do it right now. To do. And then the inlay hints, I'm going to do the same. Expression quote AST. To do unseek empty. Okay, success. This is going to now say that the core syntax over here. So now we can construct the expression, right? Can I? If I did it correctly. So I have the body, which is the AST, and I'm going to construct the expression, which is this body. Okay. Let's see. Let rec construct ast, and this will give me the expression quote ast expression, right? So I'm going to construct the body. I'm going to initialize expression like this. Actually, you know what? I feel like this should just return expression. We just construct the body. I think I made one mistake in the definition of this type here. The child, if this is an AST, it's not going to be expression quote AST, it's just going to be any expression. And then this expression must be evaluated to an AST. So it might be like a quoted one. Right? Yeah. Yeah. The unquoted one. So yeah, when I quote the AST in the interpreter, this is going to be not quoting the child. The child. Like this over here needs to be, the child must be evaluated. So I need to evaluate state child, and I need to match this with, like, child is that. And then I'm going to say that if child, I'm going to match child shape with fail. Child must be AST. So if it is a child which is AST, then we have AST like this. Okay, so now we have that stuff. So I need to convert the AST into the AST that is quoting itself, basically. Potentially checking for the unquotes inside. Or it can also be a constant AST, right? So I'm going to match AST shape. These are the ones. So to do, if it's an error, I'm going to just do that. I feel like, yeah, error or simple is just going to return it as is. So it's going to be an expression constant, where value is AST, which is the AST itself. Like this. If it's a complex one, though, then we're going to rewrite it. So this has a rule and root, right? So this one is going to be expression quote AST. AST span. Expression quote AST, where we have the rule, we have the root, right? But the root must be the root quote AST group. So root is construct group root. Okay. And construct group. Group is AST group. This should return expression quote AST group, right? Okay, so quote AST group has a rule and children. So rule is group rule, and children is group children to map function child, which is AST child, and this should return expression quote AST child, match child with group child group, like it's the other way around basically here, right? Then we are going to construct group child, and this is going to be group like this. If I have the AST child, then it's going to be AST, where this child is going to be just constructed, right? So just construct child. Unknown value child group. There you go. I mean, that's basically it, actually. The only thing that is missing here is the unquote. So if the complex stuff here is specifically the unquote, then we're going to unquote it and we're going to produce the different thing. Let's see though if I can do something like this. Echo 123 cast eval, right? So I can evaluate 1 2 3, right? That's easy. But we can now say quote, and inside of the quote, can I make it so that like that the dash doesn't do that? So quote 1 2 3. There we go. So quote 1 2 3 is now returning, instead of the 1 2 3, which is just a number, it's actually the AST. You can see that this is written differently. And now if we have 1 2 3, if we have 2 plus 3, then this value is just the AST, which is adding number 2 and number 3, right? So now we can construct the AST. I just cannot do the this thing, the unquote, like this. You know what? I just realized that we must actually not require the parentheses here for the unquote. Unquote does not need parentheses. Because we might want to have multiple quotes in a row, like in Lisp, because this is just like Lisp, right? Keyword as argument is scope 3. Yeah, this is like right associative thing. That's right. There we go. So now we can unquote, right? But the unquoted thing should actually not be present in the thing that I'm doing, unless I actually want to construct the AST, which is the unquote AST. In which case we are going to use the double backslash. So double backslash will unquote it only once, and we will keep the quote inside, right? That's the idea. Wait, do I just have... Oh, skipping unexpected. Oh, yeah. Because it thinks that it's a single... What? What's happening over here? It thinks that it's a single token right now. I guess I will change the lexer a little bit. Lexer. Backslash should be a single quoted one. What? There's something wrong with this. Oh, is it because the backslash is because of the of this quote here, and because I'm in a bash, I'm in a zesh, right? Like it only counts the 2 quotes here, even though I said 3. That's probably what happens. Alright, anyway. So we just need to have the unquote in the over here. So I say that oh, I tried looked at address. Yes. I didn't try it. I mean, I looked at it. When rule name is equal to core core unquote. So if I have unquote, then I'm just going to say that unquote thing is going to be root to root children unwrap pupil unwrap single unnamed into ast child expect ast. So we have the thing that we are going to unquote. Now we're going to compile this thing inside. So I'm going to say unquote is compile the thing that we have inside, and then I'm going to return the expression, which is this thing. That's literally what I need to return here. I think that's all. But this obviously is going to say that expression child must be AST. I'm still panicking instead of like continuing the errors. So what I can do now, let's see, example. Restart cast language server, right? I can say that let AST be quote 2 plus 2, right? So this is AST now, which is quoted, and I can say AST2 is quote 2 plus unquoted AST, right? Like this, and this should just work. I don't have a way to show it. Oh no, I can show it if I just evaluate this file, cast evaluate examples. Example, right? So this is going to be an AST, which is adding 2 and adding 2 plus 2. So this already works. Nice. And the last thing that is missing then is actually implementing this pipe, right? So whenever I implement the syntax, we're going to have a function that constructs the AST, and then we're going to compile that. So in the core syntax, let me do this, quote AST. In the core syntax, when I say impl syntax here, right, I already am associating the function, right? Yeah. Actually, I guess it means that... I guess it also means that in the standard library syntax here, this should be... Right, so this is a function that returns an AST now, right? Yeah, there you go. Argument, although, should be inferred to be AST2, technically. And then whenever I have cast compiler, I see a complex one. Cast run, guess a number. To do compile syntax rule over here, right? So if this is not a core syntax but it's a user syntax, then this needs to be backed by the thing. So I'm going to match hash table find in the state custom syntax implementations. I need to find the ID of the rule ID, right? So if it's none, then it's going to be this. It's going to be saying that must implement rule before using it, like that. And but if we have the implementation, then I'm going to actually call a function here, right? So we need to have interpreter, and we need to have interpreter evaluate. I need to evaluate an expression. I just initialize the expression here because why not? We have expression call. Expression call must have... it's called apply, right? Apply instead. So apply has a function which is a constant, a constant impl, and we have the argument, which is argument, also a constant argument. Okay, so the argument is going to be the all of my children here in the root. So I'm going to say tuple root children full map ast child expect ast for now. And then I'm going to so this is all of my arguments. All of my arguments is a tuple. It's a tuple of ASTs. So every AST is going to be a function AST into shape. So this returns like a value, right? And values. Values are ASTs like this. This AST like this. So this is my arguments, which is a tuple of values, and then arg is value, which is a tuple of our arguments, like that. And then we call that function with that, and then the result must be an expression, so the function should evaluate to another AST. AST, and then we just compile the AST. We compile the result recursively like this. And if it's not AST, if it is anything else, then we're going to error macro expanded not to AST. And then we're going to initialize error. Okay, I think that's all. Let's see if it works. Must implement the rule before using it. Okay, so it was not done actually. Why not? Is this not evaluated? Maybe for some reason it was not. Oh wait, hold on. I know why. I do the standard library and then I do the outside of the standard libraries. The way I'm initializing this thing, right? I have the bootstrap compiler, which is a different one. And then over here I create a new syntax implementation. So this should come from the bootstrap. I think maybe that's the way. There you go. It works. So now we can have custom syntax defined through macros. This works. Right. Do I have auto-completion for this too? I guess I do. I cannot really hover this though. It's weird. Yeah, I need to like fix the spans probably. Now I can pipe. And custom syntax example. Do that later. Yeah, this works. For now, this is good enough. Test compiler. All right, expanding the custom syntax using macro functions. All right, that's going to be it. I need to go. Good progress. Thank you guys for watching.
Yeah. Mm-hmm.
Hi.
Then I wonder if I should just alias here, or do we have other stuff going on inside of here? We'll come back to it. Because we may also delete that, too, is the thing. F? For me? What? More like Cedric? The problem is I don't know that I want to change every single instance of